Hello everyone and welcome again. So let's talk about Houdini. And I'm going to go to I'm on the side effects website. I'm logged in. I'm going to go to the download section. And this is where you can download the latest version of Houdini. I've been running 19.0.531 and they release the major Houdini versions and then they keep releasing updates to it very frequently. And so you can download either of them. This one has a system where it's basically a small app that you install that will allow you to download Houdini and switch versions, install plugin. I still use the old school installer, so you just get the exact file and then use that. And depending on what OS you have, you click on the button and then that will give you the version. And let's talk about the licenses. So if I go to buy, there's different versions. The Houdini Apprentice is free and they can use it. It has some limitations, but mainly the watermark, the resolution of the render file, and then you cannot export Alembic, or basically you cannot export data out of the of Houdini to other applications. And you cannot install third-party apps like Redshift or Arnolds or any other plugins or Axiom or any other plugins that needs a Houdini version. So the best option for a freelancer or artists who are making less than $100,000 is to get ND. I'm going to go to compare to quickly explain this. And so we're going to start off with the basically Apprentice, which has few features. So the has few limitations. Sorry. So you cannot use the IFD, which is honestly quite advanced features. But you cannot, you have to render, it will render with watermarks, and you cannot export data using FBX or Alembic, so basically to other applications. And but you can import. And then anything you create is going to be called HIP-NC. So the default file format is HIP, which is the full extension of Houdini files. And then NC is for non-commercial. So all your HGA, USD files, pretty much anything that you save out of Houdini, that is Houdini format, will have NC. The indie version will have LC. So it's a different one. And then if you're using Houdini full and you open up any of this file, your session will convert. And you can check this this list here for this matrix basically, and then each one will have a different price. So yeah, it really is up to you which version. I highly recommend the indie version because that is the most accessible one and it offers the most flexibility. You can install third parties, you can render 4K, and it is the cheapest version. So $269 or basically $400 for 2 years. And then you have other options for like float or node locked and stuff like that, which are which only are meant for advanced freelancers. So if you are already doing that, you know exactly what I'm talking about. And then they have two versions of Houdini. So they have Houdini Core or Houdini FX. And Houdini Core is mainly for lighting and shading and compositing. So this is what they have, like building terrains, building environments, and rendering them. Anything that requires sim is not included in the Houdini Core, and it is about 2 times cheaper than Houdini FX. So if you're a lighter, and mainly this is for studio, they get it for lighters. This is the perfect license to do that. So that's really it. And then under the what's new, you can go into the documentations and see what has been added. So honestly, every release is just an explosion of, you know, features. Every time it's a lot of work for us as educators to keep up with what they're doing and, you know, teach you guys something useful and how it actually is meant to be used, because side effects is just ahead of everybody. And then the other thing I wanted to talk about is the updates. So if you go to download, it's 589 right now, and I'm on 531. And what I do is I don't download right away. Hopefully this is not gonna, so yeah, you see already the build of today is 590. And then if you go to the documentation, if you click on this book here, you can check your version. So let's say I'm on 531 and today is 5, or the next production build is 589. I can click submit And then if I reported a bug or something, I can search for it and see if it's been fixed. But I mainly check these features, and if I see something that I need or a new fix or something that I care about in this list, whether I can search by type, if I'm into karma or I'm running sims and I have sim issues, I can see if that has been fixed. So at the moment, I don't see anything crucial or critical for me to, jump into updating everything, because it's a long process for me. So yeah, take a look at this before jumping onto the newest feature, because you have to decide whether it's worth it or not. So that's how I do it. And then, yeah, you can get Apprentice and it should work. You only need internet connection. And then the other thing I wanted to note is they have another version, another type of license that is not available for public. It's only for schools and educators, basically. It's HipNC. All the files are saved as HipNC. So same as Apprentice, but it's not. It says education here. So Houdini FX Education Edition. It's a full Houdini version. It's exactly the Houdini FX version, except that the files are HipNC and then any HDARNC. So I can use Arnold here. I can use Redshift. I can use any third party. I can do pretty much anything. But if you open this in Houdini Apprentice, it's not gonna work. So like if I use Arnold stuff and then you only have Houdini Apprentice, it's not gonna work. So you can think of this as a Houdini full effects version. And unfortunately, if you import any of the OTLs that we're gonna create, it's gonna be it's gonna convert your scene to HipNC, from HIP to HipNC. So that's the type of license I use, and I just wanted to point that out. So get the Houdini version you need, get it installed, licensed, and let's get started. Thank you for watching, and see you in the next video. Hey guys, and welcome back. So I just started Houdini for the first time, and this is how it looks like. Now the two colors here on the viewport are different, and we're gonna see how to change that in a second. So this section here has a blue color. In your case, it's gonna be gray, and the viewport is gonna have a different tone of blue. So it's gonna be lighter overall. And I'm gonna show how to change those in a second. But this is the interface, and to keep things simple, very, very simple, I'm gonna hide this. That's the shelf tool here. I'm gonna hide it, we don't need it. And then here, I'm gonna close this. I'm gonna click this X here and click this X again, and one more time. And now I'm left with two UI, two sections. And this is how I like to work with Houdini. This is my interface all the time. If I need, if I know I'm gonna be doing a lot of debugging or a lot of checking, I split this pane, this tab into two. So here, if you click on this arrow under this section, you will be able to split top and bottom. And then I can add whichever second UI or interface I need. And in this case, it's going to be the geometry spreadsheet that I most likely will need, or any other UI. So if you need to do that, you can. And then I can click here again, and I can say close pane, all tabs, and then it's gone. And you can click on these arrows here, and it will snap it. It will close this interface. So here, for example, there's a hidden UI already, and if I click here, it will show up. It's called the tree view, and this is similar to how the data is displayed in Maya, like an outliner, basically. If I hit tab, create a geometry node, you will see that it shows up here. So that is already in the UI. So you can do this to hide interfaces or add items and keep them tucked in, and or do the same thing here for the split that we just did and hide it at the bottom. And this is my interface. So in Houdini, the reason I hid the shelf tool is because we're not going to use it. We're going to use it in a bit, but overall it's just a waste of space. We're not going to use this timeliner for now. We're just going to be modeling or working on a single frame, and then you can hide all this as well to just keep the interface simple and not confuse you guys. So to create nodes or to create data in Houdini, or basically work with Houdini, We're going to hit tab, and this is the initial types of nodes that you can create. And the main, the top three ones that we're going to be using is a camera. We need a camera, and we're going to need a geometry node, and sometimes a null to move things. So I'm just hitting tab and typing in the name of the node, and that search will automatically filter out and give you the node name. And then for the geo, just hit tab and type in geo. Let me turn on a feature to display the shortcuts screen key. So now anytime I use a shortcut, you're going to see it here, and if I type something, you're going to see that happening. So let's do this again. I'm going to delete all those nodes, hit tab, and let's say I'm going to create a geometry node, or let's create a box so we have something in the viewport. Let's create a camera, hit tab and create a camera node, and let's create a null. So this is mainly what the top level nodes that we will need. And if I restore that UI back, the tree, where I can hit Shift W here, it will also give me a quick tree view here. So let's hide this. So a quick tree view inside this pane, and I can see my nodes, and I have a box, camera, and a null. I'm gonna hit the P button to display the properties of this node. So anytime I select something, we're gonna get the controller or whatever options available for the camera, or whatever I am selecting. So in this case, if I select the box, we can change the size, we can scale it. I can select the box, hit enter in the viewport, and it will give me this handle to move the box. And this handle has a rotation and translation. And now we're transforming the upper level of the geometry. All right, so let's take a look at this. So here we can just type in values by hand, or we can middle click. And if you middle click, you will see you can move the cursor to the right, and that will increase the value. If you go to the other side, it will go in the negative direction. And this is the increment. So you can change it by 1, 10, 100, or just go to something more precise. That's how you switch things. You can Control Z, I'm hitting Control Z to go back. You can select a node, and also let's see how we set keyframes. You can hold the Alt key and click, and that will set a keyframe. You can see it green here and change it green here. And if I move the timeline to 24, frame 24, and just move this up, you see now the state is different, but there is no key. I hit Alt and click again, and now I have a key. And if I play the timeline, I have 2 keys. So that's how you make quick animation in Houdini. I'm gonna shift drag all of this, right click, delete keys. And now I'm left with no keys. If I wanted to reset any value to its default, I hold the Control and middle click. So Control, middle click will restore the default value of whatever change we've made. I can Control C, Control V this node, and I can hit the T on the viewport, T shortcut or T key, and move this. It will give me the transform only. E will give me the scale, and R will give me the rotation. Next, let's take a look at the camera. So for the camera, once you create cameras, they will show up all here. Cam 1, 2, 3, 4, and let's rename it. So I'm gonna select the node and click on this text. If you click on it, it will become editable. I'm gonna call this render cam, and let me hide this tab here, Shift W, and let's hit P again to look at the network. And the reason I like this graph is because it gives me a wide space to work with, and also I want to show students or whomever is watching me how I'm working or the graph. So if it's just small section like this, it will be hard to see the full entirety of the graph, which is not so great in my opinion. So that's why I keep as the biggest possible space ever. And then if I hit P whenever I need it to control something, because this interface or that property, I don't need it all the time. All right, let's go back to the camera, and I'm gonna click on the no cam and go to the render cam, and let me open this tab here. Now if I hold Alt Alt in the viewport, left Alt, and right click on the mouse and zoom out. If I hold the left key on the mouse and the Alt key, or no Alt key as well, is the same, it will rotate. To pan over on the viewport, you hit space and then middle click, or you can also use the Alt key and middle click. And so for me, I always hold the Alt key whenever I'm doing viewport interaction, and that's how the muscle memory is working for me. So like, because it's how other applications do it as well. All right, so let's go to the render cam, and as I zoomed out, so Alt right click, as I zoomed out, you see that it changed. I'm no longer in the render cam. This is saying no cam. So to edit while being in the cam, you have to lock the viewport, and then it becomes red. And if I move the viewport, I'm repositioning the camera. And let's turn off this lock and get out. And you can see now the camera is positioned to where I wanted it to be. Okay, so let's see what else. So here I'm changing the selection and unchecking this lock here so that the selection is always free. And if you Alt double click on a surface, the camera will zoom in onto that ray intersection to that point. And yeah, I think that's pretty much it. Alt left to move, Alt middle click to pan, and Alt right to zoom in. To check the other views, you can go to set view, and now we're looking at the perspective. You can look at front, top, front, right, and also UV. And that is also stored in shortcuts, space 1 for the viewport, for the perspective, space 2 for, like you can see here, 2, 3, so you can switch viewport. All right, so the next thing I want to talk about is the settings. So you can go under the preferences, general user interface. Here I'm not changing much. Actually, I forgot to take this on, but you can tick on color pane headers with network context, and this will change the interface to be colored based on the context you're in. So yeah, we'll give you some more indication, but it's not required. And then for the interface, I don't think I changed much. So this is my 3D viewport. I use the 90 style Euler rotation, and then move pivot when panning, and then Alt key for view control. You can change this if you're comfortable with other settings. You can change this closer to how 3ds Max behaves if you're using that app or Cinema 4D. I think there's a few options that you can play with. But this is my default application. The next thing is under miscellaneous. You can see under OpenCL, you have few options. So the default is GPU. I will select the GPU, but you can also use CPU for OpenCL. And generally, it's best to use the GPU for all this calculation. And yeah, I think that's it. I don't change much here. And then the next thing I want to show is how to change colors. And for this, I'm going to show a cool tool that is provided by default in Houdini. So to look up help in Houdini, you can hit the F1 key, and that will open a separate tab for help. And you can look up any node name or anything really, and then here I will show you, and they have examples and a lot of things to look for. And I do have a path that I want to paste here. This is the local documentation, so I'm going to go to Python panel, viewport color editor, and I'm going to click load. And you have to make sure that this is being launched while Houdini is open, so through the F1. And if you click load, it's going to open up this tab. I'm going to move this to the side. And this tool here allows you to edit the viewport. So if you want to change something in the viewport, you can use this tool. You can use this tool to do that. And let me see. So right now we're using the dark theme. So I'm going to change it to the dark theme. And this is my, where is it? Active paint color, I believe. There's a background color. I'm trying to find, where is it? Yeah, bottom background color. And I think we can do like this. Hit apply. And if I change the viewport, let me hit save first. If I change the viewport, it will change. Let's go to light. Yeah, sorry, it's the light one that I've added. You can see the color here is different. The background color is different. So let me change that to something darker and hit save. And if I switch tabs, you will see the colors have changed now. So you can use this tool to edit the color of the viewport. I personally use the settings that are stored in the file, but this is also a great way. There's one more control to, I'll provide the file path, by the way, to access this and load it, and you can play with the settings that you want. So the next thing I'm going to edit is this file called, so this file is located here, and it will be under the Houdini version, Houdini config node graph dark .inc. And under this is where I change the color of the node graph, and this is the graph background color. This is the color I use. So if you open and edit this file, you can set this to this value and it will match my color here. Now we've changed the viewport, we changed the color. All we have to do to save these settings, so next time we open it, is to go under build and save current desktop. And I'm going to override the build. So these are different UIs. I'm going to change them in a second. So you can save current desktop, override this, or you can save custom and then make sure that that is being selected so that when you open it, it launches that. And then you have a few other ones predefined by side effects. So for games, they have this. For animation, they have different tools because animators probably want access to the animation graph. And then, yeah, and then a few other ones for lighting and Solaris. See Solaris, other tools that are meaningful for this workflow. And for me, I just use the build and override this, and that's what I use as my interface. Sorry, stuck here. All right, let's continue learning more about Houdini in the next video. Thank you for watching. See you in a bit. Hey guys, and welcome back. So let's talk about Houdini data and start using it. I'm gonna hit tab and create a geometry. And this is where most of the data, or most of the time, we're gonna be working. Inside this is where the majority of Houdini lives. Right now we are the object context, the OBJ context, and this is, you can see the name here. But we want to go inside of that. So under the geometry node, I'm going to double click, and now we're inside the geometry. And this is the SOP context. It's the geometry, the SOP is in the OBJ context. So I'm going to create a grid. I'm going to hit tab and create a grid. And the way Houdini works is you first initialize data, and then you process that data, and then you either submit it, send it to the render, or save it to disk. And you can think of this as a car. In the car, you have the engine, and then the engine will receive some gas, and then that will go through a process, and it generates, rotation and heat. And that's basically how Houdini works. You have data, you have an engine that processes that data, and then you have a result. And so in this grid here, I'm gonna process this data. I'm gonna do something to it. So what I just did is I pressed the W key to switch between wireframe and flat shaded. And I turned on the points because I want to see the points, or if you're coming from other apps, they're called vertices. But in reality, they're just points. So let's keep that displayed, and let's put down a jitter node, point jitter. And to connect nodes in Houdini, just drag, click here, and connect it to this node. Or you can do drag and drop right away without clicking. So just one click, but drag and drop and release here. To view this node, you can click this rectangle here, the blue rectangle, or you can hop over and you will get this circle that has the option to display. Basically all these four, they're just in the UI, in a circular UI. So you can view result by clicking this blue rectangle here. And if I wanted to go back to the grid, I can view the state of the grid like this. And we can also template things. So I can view this result, but also template or view like a ghosted version of this grid. So you can see that's my grid, and this is my resulting points or grid after this process. And then we generated data, we changed that data, and this is our result. We can then save it to disk using, for example, a ROP geometry output. So we can save this to disk, and I'm going to hit the P to get access to the settings here, and we can save it to disk as test.geo.sc, and that's Houdini native file format. So let's select the node and hit delete. The other way you can view nodes is by holding the R key and dragging. So if you hold and drag like this, you will switch the viewing of the nodes, and that's how I do it basically most of the time. So this way you don't have to click here specifically. So if you hold E and drag a rectangle, it will template this node, and then I can uncheck it here. And if you hit the B button, it will disable the node, which is this one here. So I can disable a node and can continue adding more nodes. So I'm going to create a subdivide node, and I'm going to hold the R key and drag to view this result. And that's my subdivided geometry. You can move this over to increase the subdivision, and now we have points. And in Houdini, the majority or most of the time, we're going to be working with points, primitives, and in some cases, edges. You are not going to hear the word vertices very, very often, if not at all. So let me create a grid, let me create a box. Hit tab, create a box, and let me try to explain this point versus vertices idea. So in Houdini, pretty much everything is points. The starting point is points. You start with points, and then from there you get primitives or faces, and these are faces. And right now I'm using the selection mode. If I click here, you see selection mode is set to primitives, and I'm able to select these faces. Okay, if I right click here and change it to points, I can now select these points like this, and I can select them, press the T, and now I get an edit node where I can move these points. I can disable this by holding the B and drag, and I can also change it to edges and select the edges. So let's make sure the selection mode is there, so like this, and I'm going to select this edge and hit the T key and move this again. So now I'm in selection mode, and you can change the selection mode like this by hitting W3, like you see here, 2, 3, 4, and 5. 2 for points, 3 for edges, 4 for primitives, and 5 for vertices. So the idea of points versus vertices is that you can have a point in Houdini by using an add node, and that is a single point. If I middle click, you can see properties about this node, and this middle clicking is also available through this I. And this is where you get the information about this node. So now we have 1 point, 0 primitives, 0 vertices. In order for us to create a primitive like this one, a single face, this is called primitives, a primitive, we need vertices. The vertex will attach that point to the primitive. And in the case of a box, this we need vertices to be able to describe the per point normal. So when we render this, we need to have vertices, and in this case we're going to get 3 vertices, vertex 1, 2, and 3. Each one will be associated with a face and helps construct a face. So in Houdini, you can have as many points as you want, but you don't need to have vertices. And honestly, most of the time we don't need to deal with vertices. We only work with points. And you will not hear, you can completely forget about vertices, and if we need to process them or work with them, I will let you know. But to keep things simple, we have 2 things, points and faces. And we don't call them faces in Houdini, we call them primitives. So I have this box here, and I can select it, hit enter in the viewport, and now I'm editing the default or these options. So I can select this arrow here, move it, and you can see how that is changing the box size in Houdini. Okay, let's copy this, Control C, Control V, and I'm gonna move it. Actually, I'm gonna make it smaller. and make it bigger, move it down. And I'm gonna merge them. So I'm gonna use a merge node, create a merge node, drag and drop this here, drag in, and also I can grab from the merge and bring in connection into it. And if I view the merge, I'm combining these two. I'm gonna hide the grid so I can see this result. And now I'm merging this data. If I middle click here, I have 8 points. If I middle click here, I have 8 points, and here I have 16. So we'll combine them. You can also run a Boolean operation. So I'm gonna hit tab and create Boolean. I'm gonna connect this one on in geometry A, this one geometry B, and view this, and I can see the result of this operation. You can create a bevel node, poly bevel, connect it here, and you can see the lines are changing to green. Under the distance, I'm going to increase this value. You can see we're getting the bevel now. I can change the number of division, and we can change this to flat wire shaded to view the polygons and the wireframe at the same time. Okay, it's also selecting this primitive, which is because of that Boolean result. We can expand this UI here, take on ignore flat edges, and you will skip subdividing that or doing a bevel on that. And this is our new geometry. I'm gonna put down a subdivide node and subdivide this grid. And now you can see things are not that great. And the reason for that is because we have n-gons. So if I select the 4, change this mode to 4, you can see this face has many vertices but no triangulation. So what we can do is we can put down a divide node by hitting the tab, and it can drag and insert it here. You can see how it snaps like that. I'm just going to leave it there, and I'm going to view the result. And now my data or my result is divided. So if I subdivide now, things are much better, and it's going to behave much better. Now obviously my geometry is not great, but that's how you can fix some of the n-gon problems. I'm hitting the control X to cut the node and basically deleting them. So that's a shortcut that I use. All right, so everybody talks about Houdini proceduralism. Let's see. I'm gonna select this. I'm viewing this node. Okay, I'm gonna select this box and expand it and see how the result is changing. I'm gonna go all the way out. You can see it's still working. All right. So that's how Houdini proceduralism works. You can change the input data, and the same process, the same operation will work. So let's create a grid, and let's have this grid be facing the XY. I'm going to change the number of division to 2 and 2. I'm going to extrude it, use an extrude node, and give it some thickness. Push this line here, red line, which will change the distance. I'm going to take on output back, and now I have a box. Okay, let's go back here and let's create another box, a smaller one like that. I'm going to use a copy node, copy and transform, hit tab and type in copy and transform, and I'm going to view this result. I'm going to select the copy and move to the left, to the right, and increase the number of copies to something like that. I'm gonna shift template my grid, and you put down a transform node. So hit tab, put down a transform node, and move, select the node here, hit enter on the viewport, and move my geometry to be in the center. And let's move it down as well. And I'm gonna use a Boolean node. I'm gonna put down a Boolean node. Let's move this extrude or disconnect it. And a great way to disconnect nodes is by holding the Y key. You can see the cursor changed into a scissor. I'm gonna just drag. You can see that we cut the wire. So that's a quick way to disconnect the nodes. I'm gonna drag and drop this line here, and drag and drop this one here. And we are getting some result, but it's not great. We have to set some setting in to help the Boolean node understand our data. And the A is a surface, so I'm going to tell it that it's a surface, and the second input is a solid face. But so far the result is not that great. So let's change it to intersect, and let's try subtract. I would expect this to work right away, honestly. It's a very weird problem that Houdini cannot deal with such a simple Boolean operation. So what I've done is I increased the number of division. And this is just confirms how untrue the proceduralism idea that everything in Houdini is magic. And I just wanted to show that it's not. So I made this system, and I'm going to go and copy, add another copy here. And I want to copy these boxes again. I'm just going to move them up. And I'm going to increase the number of copies. And see the Boolean operation is working. And I'm going to use an extrude node now to give this some thickness. And now we've made some sort of a building window, or building. Yeah, a building facade. I'm going to copy this again. And instead of this mode, I'm going to say intersect. And this will give me windows. Okay, let's use a divide node. And I'm seeing some edges here. I just want flat edges. Sorry, I want just grids. I don't need any subdivision in this end. Let's see if this node can help me do that. There's this feature called remove shared edges. So let's view this. Turn off convex polygon and turn on remove shared edges, and boom, everything is gone. All right, let's try something. Let's put down a subdivide. I'm just gonna create something that may not be super realistic. Very weird that the result is different for the subdivide. So there's definitely something here. Yeah, you can see after the divide, we have more points on these faces that are not needed. So let's add node, use an add node, see if I can fix this. Nope, it's not working. Let's see if how can we fix those points. Let's put down a facet node. And yeah, so there's a lot of trickery in Houdini, even with this simple example. So because we did that divide and we got this grid, we ended up with these extra points. So the facet node is used for many things. And we're going to be using it many times in Houdini, so don't worry. And one of the features that it has is remove inline points. And basically, it tries to optimize the number of points to give you the minimum points necessary to describe that curve or edge curvature. So, and it decided that those points are not needed to describe this edge. So it can be described by 2 points, and that's what you got back. All right, let's put down our subdivide node now. And we got that subdivision. So I want to make them 8 by 8. I'm going to put down another facet node, and I want to convert these entire grids into individual primitives, because now they are a group of primitives. We can do that by turning on unique points and cusp primitive. And now if I double click, by default, it will select connected geometry, select group or connected geometry. And by double clicking, it will follow the selection of what is together. After this facet node with these two options turned on, it is individual primitives. So I can put down a primitive node now and scale these primitives on their local axis. Using a primitive node, turn on do transformation and scale them down a bit. All right, let me extrude them a bit, give them some thickness, hit enter, move them back, turn on output back, and then I'm going to give them a color. So color node, and let's change them to be blue. Let's copy this node and change the building to have something brown. All right, let's merge this together. And now we have created some sort of window glass, and I'm going to transform them back. Put transform node, can slide it here, and then move the glass inside. So now we created a simple facade building. Right, now back to the real magic. I'm going to go back to my grid and change this. So let's say my building is this size, and it's working. And you can see how it's popping in and out. So things are not that procedural in Houdini, and a lot of times when you create systems, you have to solve a lot of problems to make them work. And see how that top is squeezing? It's because we are driving the size of the whatever we're creating based on the remaining or the difference. So if this is small, that division, subdivision will still be the same and work the same. So that's a quick example of how Houdini works. And then from here, we're gonna move on to create some cool particles. So let's create a grid, and I'm gonna set this to 2 by 2. And on this grid, currently we have points. So when we're dealing with particles, we want to add points or work with particles. And in this case, 4 is not enough. So we can start subdividing this, but it does not make sense to create a lot of polygons. And Houdini comes with a great node called scatter, which can generate points. So let's make 100,000 points. And right now I'm displaying them as big circles. I'm gonna right click here under this checkerboard box. I'm gonna change it to pixel, and that's my points. I'm gonna turn off relax iteration. I want the points to be randomly distributed. I'm gonna create a noise node, attribute noise node, and I'm gonna connect it here. And this is, right now it's generating a noise on the color of the points. I don't need that. I'm gonna change this attribute to P. So what is the CD and P, and what is happening now? If I middle click, you can see I have one point attribute, P. And in Houdini, there's 4 different attributes: point attribute, primitive attribute, vertices attribute, and then detail attribute. So point is a per point attribute, like a position. Position is a per point attribute, or a normal is a per point attribute. Let's create a sphere. Let's put down a facet node and tick on post compute normals. And now if I middle click, let's turn this off. If I middle click, we have P, position. And if I tick this on, we have P and N. N is the normal of the surface, and it is a point attribute at the moment. If I display this, if you hop over, it says display normals, and that's what the normal of the geometry looks like. So we can display attributes, and we can click here and see all these properties. I can click on N, and it will create a custom display for that specific attribute. I can do it for P as well, and in this case, it's showing me the data as a float, so X, Y, and Z for each point. But where is this data? Where is it coming from? Well, if we right click on this node and go to and click on spreadsheet, it will give us this geometry spreadsheet. And we do a lot of time looking at this data. So in Houdini, everything is data manipulation. So we're going to be creating attributes, processing them, maybe not for the first couple weeks, but once we start working with particles and doing magic stuff, we're going to be working, looking at this. So this is the point attribute, and you can see we have how many points, 266 points. If I scroll all the way down, that's 265 points, but they start at 0. And each point has an attribute, has a P and N. And so what we did here, we took that P attribute and changed it. And we are seeing the result of that. We can also use CD, and CD is a color attribute, and it is displayed in the viewport by default. If you want to hide it from the viewport, you can right click here, turn this off, geometry color, and it should display, should turn off. It's because, yeah, this is different, but yeah, if I put down a color node and set these points to red, and then right click here, sorry, I swear it should be working. What is happening? It should not be displaying vertices, the point color. This is how you override that. But I guess Houdini decided to behave differently now. Anyway, those are the options for that, and you will see them being used later once I figure out why is it behaving this way. And this CD attribute, now we're coloring or adding noise to the color attribute. And if I middle click, now we have a color attribute that is being created here. So if I set this to P, we are deforming the points. And this is how we can create some magic effects. So if we shade this and make them accumulative or increase the number of points, let's say to 100,000, we can, and give them some transparency, we can get some cool results. So let's do that. Let's create a quick color attribute and give them maybe a blue color like that. And I'm going to create another wrangle. Don't worry about this yet. I'm going to say f at alpha is equals 0.5. And again, don't worry too much. Let's lower it to 0.1. And I'm going to change the background because I want to see this over black. So I'm going to hit the D on the viewport, change this to dark. And now I'm looking at this over a black background. All right. This by default has an option to be animated. So I'm going to click on that. And now these points are animated. If I hit play, you can see we're getting some cool particle effects or very basic particle effects. And so we've created a grid, scattered points, added an attribute on them, and then added a color, and then gave them a transparency. And this is what that expression is for, to make the pixels transparent in the viewport so we can see them being accumulated. So let's restore the viewport color. This is only in the viewport, so light and dark 2 mode. And I think I explained quickly the attributes. So we have P and we've created N and we've changed that P. So if I look at the data here, right click, let me lower the number of points to 1,000. So right click spreadsheet, that's my number, that's my point position. And then if I look at that data again here, you can see that each point has a different value. So we are changing the point position. And let's increase this so we can see it, and we can turn on that randomization to make the points better distributed if we want that. All right, I think that's pretty much it. One thing I forgot, which I think you guys have noticed, is how I zoom in and out in this. So middle click, you pan, and then if you use the wheel up and down to zoom in, you can select a node and hit F, it will zoom in into that node. And then with the P to show this, and to disconnect Y and drag to create, use the scissor, and then to connect, you drag and drop from this into this. And that's really all there is. We're going to start diving into more serious Houdini modeling now. Thank you for watching and see you in the next video. Bye-bye. Hey guys, and welcome back. So let's learn more about Houdini data and how to use it. So let's create a grid again, and I'm going to scatter some points. Actually, I'm not going to scatter. I'm going to increase the number of points here to 50 by 50, and I'm going to create a noise attribute. And right now we're using this function, and it's changing the CD attribute. And see, now it's not displaying. So this is how you turn it off. I'm not sure why it's not behaving. So make sure that you are aware of that. And I'm going to affect the P position. So we changed the points. We added noise to them. And in the previous case, we were just using points, no primitive connected, no triangulation between them. And if I use an add node and delete geometry back key points, you see it's all points. That's really what Houdini is about, points manipulation. So what is happening? What is this doing? I'm going to create a point VOP, and this is what we're going to be using on a lot of examples and a lot of things that we do in Houdini. A point VOP, you can think of this as the point manipulator, or how to work with data in Houdini in a very selective manner, access Houdini capabilities to its maximum. And this is, I'm going to double click, and this is where you can access attributes, process them, and then send them back. And the attribute I'm interested in is P. So if I plug this straight, nothing happens. But if I add a multiply, for example, by constant, and so, connect that in between and start multiplying the position, I can scale this up and down. But all I'm doing is I'm just changing the point position. And if I go back and add that, use this add node and delete the primitive, so now I only have points, this would still work the same. It does not matter what is coming. It only works with points. That's all it cares about. If there's primitives, great. If not, doesn't matter. So let's delete that and add some noise. Let's create a noise node. So I'm gonna hit tab and create noise. You can use any of this, not any of that. Let's use a turbulent noise. And a noise function will need an input all the time. You have to feed it something and it gives you back a noise based on that. So in this case, we're gonna give it the point position, which is unique per point. So we're feeding it that. If I connect it here, it will just get messy. Nothing will make sense. And right now we're giving it a three vector or 3 floats, and it's giving us 1D noise. So I want to change it to 3D noise. And this is what it looks like, but this is not useful. I want to use this data to add noise to my points, my current points. So how do we do that? Well, we can use an add node and say, this is my current position. I can plug it in and my data is back. Or I can also add this result to it. So now we're adding this noise on top of the point position. And we have few types here. We can use a zero-centered Perlin noise. So let's do that. And we have few controls. We can choose the amplitude. We can choose the frequency. And let's increase the number of points. Stand it to 250 by 250. And we can increase the frequency or lower it. We can increase the roughness or lower it. And also the layers of the noise. And this is now working on points, remember? I can disconnect it and plug it directly on my primitive and look what's happening to the curve, to the grid. Right, let's dive inside. I want to change some of these settings, but control them at the upper level because I don't want to be diving in and changing something every time. So I'm going to middle click and say promote parameter. If I go up now, you'll see I have this attribute called offset. I'm going to use an expression called $f, which means $frame. So now we're using X and letting it be driven by the frame numbers. You can see now we're frame 1. If I drag this here, you can see it's moving, but it's too fast. So I want to make it slower. I'm going to click again. When I click here, it's evaluating and showing me the result. I want to see the expression. So I click again here and say divide by 10. And now I'm going to make it 10 times slower. And if I hit play, you can see the result of this moving. So let's do the same thing. Let's also change it along the Y. I'm going to divide this by 50 to make it really slow along that axis. And if I hit play now, you can see that it feels like it's moving. It's animated. It's not just static. Okay, so let's deform this geometry. Let's put down a bend node. And this is a geometry modifier. It can also work with points. And I'm going to select this node, hit enter. And you can see a few controls here. The first one is the capture distance. So I'm going to increase the capture distance. And it's starting at the center, which I don't want. So I want to move it back. Or actually, I want to move it this way. So let's change the capture direction to be 1. This way. I'll move the center here. And let's move the origin back all the way there. And let's increase the capture distance. And now we're capturing or fitting this entire box into this bend node. Now if I use this bend, you can see we're curving it this way. Let's go all the way like that. And now we have created a tube. And if I look inside, oh, the noise is moving in the different direction. So let's go back and let's change the direction the noise is moving. So instead of X, I believe, I'm gonna move it along the Z. So right click here, delete expression, and go here and paste that same expression. Let's take a look at the bend node. And now the noise is moving this way. So we've post deformed the geometry with this nice bend node. But you can see the gap, and I don't like that much. I don't like this gap that much. So what do we do? Well, we don't have to do the bend after, we can do the bend before. So let's make sure our geometry is bent before. I just cut it and paste it. And let's make sure that we're not overlapping it, something like that. And then when we process, when we use that as the point position, it will just blend in nicely. 380, it's a touch of overlap. And if I hit play now, we are getting a nice propagation, a nice noise along this. All right, so let's add, let's do one more thing. Instead of doing this on with geometry, I'm gonna put down a scatter node here and increase the number of points to 10,000, 100,000. Now we have a lot of points, and if I look at them, now they are being deformed. I'm gonna copy this node one more time. Same thing, I'm gonna copy it one more time. I'm gonna lower the frequency or increase the frequency. So this is by half and this is by half. And I'm gonna dive inside and increase the frequency to 2 and lower the amplitude to 2 as well. So we're getting more details in this one, and let me increase the roughness to get more shapes. And then we have some nice points and 2 layers of noise. Let's disable this for a second just so we can see it. Yeah, it's a bit messy, but if I hit play, you can see there's 2 layers. There's one moving fast and one moving slow. And actually I want to reverse one of them. So I'm going to reverse this and have the large layer go in one direction, the second one comes back. And I'm going to turn on the scatter to get the points, and I'm going to give them a color node and give them a blue color and use that same trick that we did with the alpha. And let's change the viewport to dark. Now we've created some magical tunnel. So if I hit play, we're getting some nice curves. It's snappy obviously, but you get the idea. Or maybe let's move them in both in the same direction. Let's change this to positive as well. So we have one layer and the second one is going faster. So that's one way of manipulating data in Houdini. We can use geometry deformers or deformers that are at the sub level. We can work with points. We can work with curves if we wanted to. Geometry. We can use point VOPs. We can layer them. We can add colors, and we can do pretty much anything. So one more thing is a lot of deformation is happening here. A lot of changes, and these points they are moving, and that movement has a value. So the change in position can be computed or put into a velocity attribute. And velocity is how fast the point is moving. It is a vector, so I'm going to use this trail node and set the method to compute velocity. And if I middle click now, I have a V attribute. If I play it, nothing has changed, but if I display this, you will see that I have some trails and they are changing as the point goes. So I want to use this to drive the color of my geometry. Let's create a point VOP. And I want to do something. So we have this access to V. I'm going to compute the magnitude of this velocity. If a point is moving too fast, I want to know. If it's moving too slow, I want to know. I'm going to compute the length. So we have a vector and we compute the length of that vector. I'm going to connect it here. So now if I hit play, it's all white because things are moving too fast. So what do we need to do? Well, we're going to use a fit range. A fit range can take a value, a high range value from 0 to 100. We can fit it into something that is viewable for us. So let's view this first, and let's go up. And here we can take a look at the color attribute and click on CD, and you can see the highest value. It's sorting the values, and in this case 15 seems to be one of the highest numbers. So let's try and set that. So let's say in this fit range, basically my input is too high, it comes from 0 to 15, and then I want to fit it between 0 and 1. You can see right away things are getting darker now and brighter based on the velocity. All right, let's put one more node. It's the last node. It's called the mix, and I'm gonna set this mix to to RGB. The mix value is gonna be this length of velocity remapped. I'm gonna plug this into a color. I'm gonna say if the velocity is too fast, it's gonna be bright blue, and if the velocity is too slow, it's gonna be a dark blue. And maybe let's set this to 10 to get more variation. And let's put this alpha after. And now we're changing the color of my points based on the speed of the geometry. And so they're fading in and out, or they're getting darker and brighter based on the velocity. So that's how we can manipulate the data and create procedural animation in Houdini. Now, there's few more things I need to explain, and that is the float vectors and integers, which is the type that we're going to be working with. So let me do that. And this is really, really simple. It's from later weeks left over. So we have three things. Let me type. We have a float. So we have a float, and a float is something like 1.01, 1.0, 3.5, or 1550.155. All these are floats, okay? And this can be any value like this, or sorry, where is it? So any value like this, 0.1, 0.05, that is a float. An integer is a value that doesn't have any decimals after it. So 1, 2, 3, 4, 5, 6, those are all integers, okay? The last type, or the last thing that we are going to be using in Houdini, is called vectors. So vectors are made of three floats, x, y, and z. A vector has three floats, one for the x value, one for the y value, and one for the z value. In case of a position, we have the position along the x-axis, y-axis, and z-axis. And if I display the spreadsheet, you can see P. I have P, X, Y, and Z. And for the color, we have RGB, and it's the same thing. It is a vector. These vectors have length. And so, for example, I have a point, and I have a 3D system like this. 3D system with X, Y, and Z. So X, Y, and Z. So that's Y. This is X, and this is Z. And I have a point here. That point has a value on the X, Y, and Z. The distance from here to here is the vector, or the vector that we need to offset 0 to this position P is its vector. How far it is from this point is the distance. That distance is the length. So if a point is moving too fast and it has a magnitude, or a vector of 3, 4, 5 in its velocity, that vector has a magnitude. That magnitude is the speed, how fast that point is moving. And the same thing, this point, this P position has also distance, and that distance is the length of the magnitude of the vector, sorry. And so that's what we computed. And if I reduce the number of points to 1000, and let me go here to the trail and display the velocity, you can see that it is also being represented here. So by this curve. So this curve has a magnitude, its length, and also a direction. But it's not a great representation. So what I'm going to do is I'm going to click on this I here. I'm going to click on the V. That should display. And that will create a custom display for that attribute. So I'm going to click it here. See, everything is exploding with wires. So I'm going to right click and click on this edit here. And I'm going to change it to a vector trail. And I'm going to reduce the length scale. Actually, there's a point trail. No, not. It should show. where is it? Where is that feature? Sorry. Yeah, there's a marker. There's a feature to get an actual arrow from these. So I'm not sure. Oh yeah, so that's it. Yeah, show arrow tip, and I think it's also with the vector. No, so we'll use a vector, and you can see now the direction of the velocity. And I'm multiplying their length just in the viewport. You can see the shorter they are, the slower the points are moving. The faster they are, the faster the point is moving. And the direction of this represents the velocity direction, and the length, pardon me, the length represents the magnitude of these curves. So that's basically the three things that we need to worry about: float, integer, and vectors. And this quick example here, you can hide all of these controllers by using this. And a quick way to create custom marker, custom display, by clicking on the attribute, and you can right click and then use this arrow pen here to edit it. Okay, I think that's pretty much it for this video. We're gonna talk about a few more settings and how to set shortcuts. Now that we understood how to navigate and how things work in Houdini, I'm gonna talk about a few things and how to make the workflow a bit more efficient. Thank you for watching, and see you in the next video. Bye-bye. Hello everyone, and welcome back. In this video, I want to go over some Houdini shortcuts and the customization I have installed that will hopefully speed up your workflow and allow you to work faster in Houdini. And the first thing and most important thing that we want to learn about is where all the options for the viewport are, because they will affect how you see things in the viewport, and they will affect what you see in the viewport. On the viewport, be here, press D, and this is pretty much all the options available that would affect how you would see things from the OBJ level, from the geometry level into Houdini: volumes, geometry, curves, anything really. And by default, you don't have to do much. And the majority or the most important settings that are available here, the most important settings that we generally use have a representation here. So for example, this would display the points. You can see it's toggling that. This would display the normals. This is primitives. This would turn on and off turn back faces. Pretty much the most important features will be visible in the viewport. So let me create a grid. The main option that I change is I don't like the origin gnomon. So this floating, let me hide the viewport. Let me hide this object first to show it. So see that XYZ red thing? I like to hide it. And then you have this floating one here on the left. I keep that, so I like that one. And then tint back faces, you would probably want to be using this, but now they have it exposed as well. And then there's this cool option for boundaries. So you can say, I want to display the boundaries of the geometry, and this is when you're working with UVs maybe, or if you want to display the boundaries of geometry, this is how you would do it. And then there's multiple other options that we're going to be using and tweaking as we progress further in Houdini that deals with volume, with lights, and various other things. But at the moment, there's nothing critical that we have to be aware of. The majority of them are here, and like display textures and display colors, geometry color. And then if we want to view things as point or pixels, this is how you would change that. So pretty much all the important options that we are going to be playing with are available and located here. All right, so the next thing is a few of the shortcuts that I use all the time. Some of them are linked to scripts that we're going to see and install, and some of them are not. So the first one is when I have nodes. So let me create a merge node. Alt drag this node, makes a copy. This is not a shortcut. This is a default in Houdini. And then I view this node. So I do disconnection using this shortcut, Alt E. So I'm going to select, hit Alt E, and it basically disconnects instead of this. And I use this all the time. If you see me, I don't know, let's put that on subdivide. If you see me do this, I extracted this node from the chain, I'm simply disconnecting it. The other thing you could do is shake it. You can shake the node, but I'd like to use a shortcut, and it's perfectly designed to fit the shortest possible keys, Alt-E, exactly where my left arm rests. And so this is super fast for me to do. And this is a default thing in Houdini. So if you go under Edit and you see Reconnect Around Nodes, let me select a node. Edit, Reconnect Around Nodes, around selected. So if I do that, it's going to move this out, but keep the chain. It's not the same as, it's not the same as using the Y cut or the knife to cut the wire. It's extracting it from the chain. And to create shortcuts in Houdini, you hold the Control Alt Shift, and then you hold them, and then you click on the button. So Control Shift Alt, and then you click, and here you will see the menu. So I'm going to remove the shortcut, and I'm going to say Alt E. Basically, this is how you would see it, or maybe it has a different shortcut. I would double click and then hit Alt E, and then hit Apply and Accept. And now that shortcut is assigned. All right. Next thing is this one, and this one is done using a script. So I'm going to select this and hit Control E. See, I've made a connection. Let me do it again using a different node. This one I wrote, and it's basically an idea that I have in Nuke as well. So you select the target and then the incoming nodes. So the target and incoming, and then you hit Control E and it will connect all of them. Okay, so let's see if I have, for example, which node? Yeah, the merge node is basically the main use case for this, but it also works with single nodes. So if you have a node, then you select this and hit Control E, it will also work. So this is done using a script. And the way to install these scripts is you copy starting from import. So it's a Python script, and then we can create a new shelf. We'll call this RW Live, and then hit Apply. And now you have a menu here. And then inside this shelf tool or shelf tab, we're going to create tools. So new tool, and you go under script and you paste that text. You make sure it's set to Python, and then you give the tool a name. That doesn't matter in this case, but we'll call it Connect Nodes, and then hit Apply. And now I have it here, but it's not yet assigned to a shortcut. So if I select this, hit Connect, it works. To assign this to a shortcut, you hit the Edit tool, and then you go to the hotkeys. And you can have specific shortcuts based on the scope. So if you are in the scene viewer, if you are over this area, or if you are in the composite view or the Orbital Asset Browser, they have this, but I use global. So I'm going to click Edit, and then the shortcut for this is I'm going to double click and Control E, and it's already assigned to something, so I'm not going to override it. And then you hit Apply and Accept, and that will be your shortcut. And you hit Apply. Cool. The next thing is the create object merge. So I do this a lot. I create an object merge to basically work and access data without having to duplicate it. So now this subdivide here is coming through this node. So just an object merge, but there is no wire. Okay. And I have script to automate this process just to save a few clicks. And then the second tool, I'm gonna edit it. It's this part here, and I will provide all this. So create in, I'm gonna copy it and go to scripts and hit Apply. And now if I select this node, let me delete. If I select this node and I click the button, it's gonna create an object merge. And look, the path is flattened. It's not relative like the default one. So if I create an object merge, by default it's relative, so it's whatever is located inside this group. If I copy this node and go to a different geometry context, it's not going to work because that path is relative. So I need an absolute path that flattens out the hierarchy, and that's how I do it. If you want the flattened hierarchy, you can either select the node, hit Control C, and then select it here and paste the path. So that copying a node will actually give you the full path, the absolute path in Houdini, and that would still work as well. All right, then you can assign a shortcut. In my case, I believe it's Alt-Shift-E. Yeah, Alt-Shift-E is also very accessible for my left hand, so I use that. And then the last most important one is the disable and enabling of cooking. So I do this a lot, and many times I wouldn't mention it because it's just a muscle memory, and you have to keep an eye on this. If I do something and you see it's happening super fast, most of the time it's not cooking. So I do this a lot because when I'm working with Sims and any heavy operation, I disable it without even realizing, tweak my settings, and then enable it back like this. So this is another script that I have here. I'm going to copy it and create another tool and paste it, and we'll call this on off and hit apply. I'll also provide the shelf tool. You can just copy it, I believe, under the Houdini 19, under the My Documents, Houdini 19, I believe there is a shelf folder where you could install this or just recreate them quickly. So Shift E to enable and disable cooking. And then the last one is to blast groups. So let's say I have data. I haven't used this in a while. So and I made it for a specific scene where I was dealing with a lot of FBX file. Let's say I have a group like this, and then a second group like this. I'll call this group 2. And let's do it one more time, group 3. And select some nodes, some faces. And let's say you want to separate this data using a blast node. And each time you blast out a specific area and you call this group 1, group 2, and you want to go over and you have like 100 groups or something, I made a script to do that. So new tool, scripts. I'm going to copy this part, hit apply. And then if you select the data and hit this tool, let's see. Yeah, I think this was done using an older version of Houdini. I'm gonna check the syntax. Sometimes the spaces can cause the script not to function properly. Yeah, I think it's because Python 3 syntax is different and this is an older one. All the other works just fine. And yeah, this would basically create 3 blast node or as many groups as you have and separate them, and then you can work with that. I haven't used it in a while, and I think you can find a newer version online that does similar things if you need this part. All right, let's see what else. So the next thing I have is I have 2 plugins installed, or like 2 libraries of extra nodes that I use. The first one is called the Side Effects Labs, and it comes in by default in Houdini, and you're gonna see me use it a lot. So if you, it's now called Labs, basically Side Effects Labs, and it's an amazing library of pre-built OTLs that the Side Effects has a different department or different team that works on this unaffected by the Houdini version. So you can get different releases of Side Effects Labs and without having to wait for a new Houdini release. And I think you can go to, I believe there is a menu now that actually updates where you can update the Side Effects Labs. Yeah, exactly. So there's this menu here. You can update toolset, and it will find the latest version and grab it. So now it's 5.9, and it's, again, I can be on 5.3.1 and download the latest Houdini Side Effects Labs, and yeah, it's a great library, and we're going to be using it. The second one is called QLib, and let me see. So this is the page for Side Effects Labs. You can learn more about it if you are interested in diving into it more. It's mainly geared towards games and real time, but there is a lot of things that we could use as well, and we're going to see that over the next few weeks. The second library is we're not going to be using this much. It's mainly for more advanced use cases, and if we run into any situation where we need them, we will use them. But basically it contains a lot of nodes. Let's see, qlib, and there's tons of alternative versions of nodes that exist in Houdini, but they made them better, and they made their their own implementation, like a volume retime. There's a PQL. There's an alternative version to a lot of nodes in Houdini and that I like, and but we don't have to use them at the moment. So you can check this out if you're interested in that, but it is not required at the moment. So that's pretty much it in terms of shortcuts. And if you see something happens that you don't know how I did it, just ask away and I'll be able to provide answer to that. But the majority is this, is what we did here, these 4 shortcuts. And then I use the Y a lot, and then the Alt E to disconnect nodes, and then for connecting nodes as well, Control E. All right, thank you guys for watching, and see you in the next video. Bye. Hey guys, and welcome back. A very important part of Houdini and creating effects is learning how to work with noise. And I want to explain a few concepts that are very important to understand at the beginning and crucial to creating effects. So I'm going to create a sphere, a circle, and I'm going to copy it and change the radius. And I'm going to merge both of them. And this is my result. I'm going to, let me change the size of this one. I'm going to use a skin node and skin both circles. So what this node is going to do is basically loft or connect this circle with this one. So it's going to ignore the 2 overlapping circles that we have and just give us one. And this is what I wanted. I wanted a surface like this. And I'm going to scatter points on this. Let's increase the density. And I'm going to use a texture node and set it to rows and columns. And what I've done in the beginning is I set these 2 circles to NURBS curves. And when we skin NURBS, we get a NURBS surface. And this is a parametric surface. So Houdini or any 3D app really dealing with NURBS surfaces, because they are parametric, they come with UVs by default. And this UV will always be from 0 to 1, and the object will be perfectly mapped. So what does that mean? It means if I middle click now, we have a UV coordinate. We can view the UVs by hitting space 5 on the viewport, and that will show us the UV. It doesn't really matter how it looks, it's a perfect UV. And I'm going to create a point fob and connect it here. I'm going to change this one to point instead of vertices, so that when I scatter points, they inherit the UV coordinate. And let's dive inside, and I'm going to connect the UV to the color. So right now we have 2 things. We have red and green, and that's the UV coordinate of the geometry. And by increasing the number of points, we're going to get 10,000 points. And you can see we have red and green here. I'm going to show you a trick on the viewport where we can isolate specific colors if we want that. So I'm going to right click here and turn on check color correction, and these buttons will allow us to view individual channels. So let me change it to dark, and now you can see we're looking at the red channel only, and this is the U coordinate. I turned off the relaxation of the points, and then if we look at the green, we get this nice gradient going this way. And this data is very important to use, or in case we wanted to generate noise in interesting noise patterns. So let's dive inside. I'm going to create a noise pattern, and we can view it as color. This is how it looks like, and we can change it to a 3D noise. By default it's a 1D noise, so it's black and white. I'm going to change it so we get X, Y, and Z information. And this is how the color looks like. I'm going to use this data and offset the point position. I'm going to take P apply the result of the noise and then connect this back out. And let's disconnect the color for a second. We don't need it. And this is how the noise looks like. I'm going to change it to sparse convolution noise, and you can see we're getting some cool patterns. Now we are using the point position into this noise, and really what's happening, the way the noise works is similar to how a random value works. A random value given any integer 1, 2, 3, you run it through a random function and it will generate a number, for example 0.1, 0.33, and just give us random numbers based on the input. Noise is the same. We have a linear value, or we have a value that goes between 0 and 10, for example, and then we feed this into the noise function, and from this it's going to give us back something like this, and that is the noise pattern. This is one idea. And instead of using instead of just doing a 1D noise or a black and white noise, we can run this and get XYZ results. So each axis will have a different result. And if you think about it, the point position is just a number, right? So we have X information here. I can sort them out. You can see each point has an attribute, and that can also be represented as this curve. So the X is this curve, the Y is a similar curve, maybe something like this. Sorry, the Y is lower, and then we have the Z, maybe it goes like this. So just data that we can use that is unique per point to feed into the noise, and then the noise gives us back something else. And so we also have the UV coordinate available, and if I use this offset on the point position, you will see that the pattern is traveling in space, right? Here it's traveling along the y-axis, this is along the z-axis, so we can offset it. So now instead of using P, I want to use the UV coordinate to generate my noise pattern. You can see it's different, so we have to increase few things. And remember, we only have X and Y. So UV goes into X and Y. So I'm going to change this to 5. Let's change this more. You can see the noise pattern, how it's repeating in a circular manner, and that's the U coordinate, right? It's the red channel. And if I display that, if I just display this, you can see the red channel goes in this way. And then the green channel, the V, goes in this from the center out. Okay, let's disconnect the color again. And so we can use this UV coordinate, which is nice and parametric, to align the noise in a different way. And now if I increase, let me copy this and use it instead. So I'm going to set it back to 1. And if we start increasing along the y-axis, we're going to get this radial pattern. And the cool thing is, if I move this out, it's going to feel that it's going outward. And if I move this one, it's going to feel the pattern is rotating. Okay, so having this parametric information being used to drive the noise is very crucial if you want things to move in a specific direction. Okay, let's see some practical use case for this. I'm gonna set this to 1 and increase this, and we can stretch this pattern to something like this. And see, now we have this cool shape or cool pattern, and we can start moving it outward. And let's go up. Let's scatter more points. Set it to 5,000. Yeah, it's very cool. And right now we're offsetting. We're taking the U coordinate and using it to generate noise, and then we're applying all of that into X, Y, and Z. I want to flatten this out a bit, so I'm just gonna do it here using a transform node, and I'm gonna flatten this like that. And I'm going to use an attribute create node to create an attribute that is by default recognized in Houdini called alpha. And if I set this alpha and give it a value of 0.1, it will make my particles transparent. And if I give them a color, we can get some cool magical like effects very, very easily. And now if I go back here and animate this offset, you can get some really cool effects going. And so this is basically how you would deal with UVs, or how you could use UVs. You can also create any geometry, really, any, let's say a sphere, and we set it into a NURB sphere, and let's go, and I'm gonna clip it. Don't think it has a clipping feature by default, so I'm just gonna clip it using a clip node. Yeah, it does not have a clipping feature. Okay, it's fine. Let's use this one. And I'm gonna copy the same nodes, all of this here. I don't need the transform. I'm gonna scatter points onto the sphere and apply the noise. Let's get this as well for the texture. And now we have the noise applied. But let's take a look at the UV coordinate first before we start offsetting it. And if we look at the red channel, it goes in this way, and then the U channel goes top to bottom. See, it's black at the bottom and then white at the top. So we can use this to drive the noise. Let's apply it back in and lower the amplitude. And let's set this to 1 and 1. And now we have this pattern. Let's increase the frequency along the y-axis as well. And now if I apply this offset along the y, we can get this shield kind of effects. All right, let's see. Let's learn a bit more. I just want to show a few more things. It's perfectly fine if you are not fully understanding this part, or if things are a bit complicated. That's perfectly fine. I'm just gonna share it, and then as we go in the first 3 weeks, we're just gonna explore this and learn more about all these fit range and mathematical functions. So we have the UV coordinate, right? And I can split this vector, which is made of, you can see here when I hop over U at the bottom of the node graph, you can see it says UV vector. And we can use a vector to float to access individual components, X, Y, and Z. In this case, I want to access the U coordinate, which is white at the top and black at the bottom. And I can use a ramp to basically take this linear function, or a linear ramp, which is this one, and remap it into something else. So we can take this function here, and through a remapping, we can make it be like this, or we can make it go like this, or we can make it go like this. Anything we want. I'm gonna set this ramp to a spline, and then go up to the upper level. You see here we have editor. By default, it sets 2 points, and I'm going to change that. Let's actually change it. Let's make sure we're looking at the correct colors. So let's see. Yeah, it is reversed, I believe. Let me check a bit more. I wonder why the color is not showing up. Let's see. So we have UV, and we take this UV coordinate. Let's try with the Y. Oh, sorry. The ramp was not connected. Yeah. Okay. So we have this ramp. You can see it's black at the top and white at the bottom. And I can move this point. And let me change it to gradient so we can see better our geometry. I can move this point, and the black is getting bigger and bigger. So what I want to use is, I want to use this as a multiplier. So if it's black, I want the noise to be less. If it's white, I want the noise to be stronger. So here, I'm just going to take this result, and this is my noise pattern. And I'm going to use a multiply, and multiply it by this map. And now if I add this noise and plug it back into P, you can see at the top we don't have any noise, and then at the bottom it's 100%. And let's promote this. So middle click, promote parameter, and what's going to happen is it's going to create a channel reference for this that is available for us to use at the upper level. And I'll talk about this in more details in the next video. Basically now we have those options that are inside accessible here. I'm going to use a $F, which is the frame, and that's going to return the frame number every frame. You can click here, you see it's evaluating. Then as they go, it's 1, 2, 3. It's too fast, so I'm going to divide it by 10. And now if I hit play, the pattern is moving upward. I want to change it to go down. So I'm going to say negative all of this. And now if I hit play, I'm going to get this cool effects. And we can apply the alpha trick again, change the color, and let's change the screen to the background to dark, and let's increase the number of points. Now we have this cool representation of the particles, and it's super fast. And this is like a very quick way to get some sort of shield around a character or a force, and the map and the pattern is moving nicely. All right, we'll talk about this more in the next video. Thank you for watching, and see you in a bit. Hello everyone, and welcome again. So looking at this pattern, the first thing that comes to mind is a eye iris. And if we look at some of the images, you can see it's very similar. It's a good starting point for this. We get this nice shapes at the bottom, and then we have this ring kind of pattern or like shape, and then we have another layer at the top. So let's see if we can build something like this procedurally. And the main purpose of this exercise is really to demo Houdini a bit more and to show what we can build procedurally without sims, and just learn more about Houdini. So I like this pattern, actually. I want to keep it. But the first thing I notice is these images, they have lines, right? They're not points. So how can we make this using lines? Right now it's just points. So let's create a line. And I'm going to try and make it match the shape that we had. So let's change the direction of this line to point in the Z direction or X, doesn't matter. Let's go with the X, and I'm going to move it here and then increase the length to cover this. Set it to 4, and let's increase the number of points. And now we have 20 points in this line. I'm going to use a copy node, copy and transform. And what this node does, it allows us to copy things and rotate them. So I'm going to move this just a bit, maybe 5 degrees. And let's increase this number. I want to get a full circle of all of this, something like this. Here we've started off with a UV coordinate. We have something that a value that starts 0 and goes all the way to 1, and then we have something else that is circular around this. So I want to have something similar as well to this one, to this information. And because the way this surface, this geometry is created, I don't have that information, right? So I'm going to use a resample node. Within this resample, what it does is, let's do it here. What this node does, basically you can turn on this curve view attribute, and it will give you a black and white or a float that goes from 0 to 1. We can view that using a color node. So let's put down a color node. And I'm really sorry, I know I'm going a bit slower than usual, but I really have to make sure that everybody is fully understanding these nodes and, getting comfortable with Houdini. So bear with me here. So we can visualize this color hue information. I can also look at the spreadsheet. You can see it starts at 1, goes all the way to 0. All right, so we solved pretty much the U coordinate. Now we need the V coordinate that goes in circle. Whether we need it or not, I'm not so sure, but we need that information. So how can we do it? Well, let's think about it. We have a primitive number. We have each point has a number. Each primitive has also a number. And if I look here, 1, and it goes 2, 3, 4, they're all in order, and then it ends at 72. So if I take 72, if I divide this number by 72, this would be 1, right? And if I divide this by 72, it would give us a starting point, maybe 0.01, and this will give us a gradient along this arc or this perimeter that we see here. So how can we do that? Well, I'm going to create a point VOP and dive inside, and I'm going to use a divide, and the prim num is accessible through here. So this number is coming through this, and this blue number is coming through ptnum, point number. So I'll care about the prim num in this case. I'm going to divide it, and I'm going to, let's divide it by a constant. And the constant here is going to be 72. That is the maximum number. And now if I view this in the color, you will see that something is happening. But unfortunately, the data, maybe we can look at this, implicit cast from float to int, use explicit cast. So it's not liking that we're dividing an integer with a float, or an integer with an integer, or connecting this. Something is, Houdini is not happy about something. So what I'm going to do is I'm going to convert this integer, which is 1, 2, 3, 4. It does not have any decimals after the 0. I'm going to convert that into a float. And now everybody is happy. No more complaints, and the result is black to white from here. And let's look at the color information. And you can see that it goes from 0 all the way to 1. All right. So one thing I didn't like is the fact that I have to do this by hand. I have to set the angle, and if I change or need more points, right now they are just overlapping. The circle is happening again. I can see double primitive overlapping. So what can we do to fill in the gap? I can say the angle is 2.5, and now we have half a circle covered. So we need to increase this, and then it's not good. So it's not dynamic. So what I want to do is I'm going to use something called channel referencing. I can tell Houdini that I want this value or this value to drive this, okay? Or I want this value to be used somehow in this. So to get a full circle, we need 360 curves, and each one of them is separated by an angle of 1. And this expression is going to give us a full perfect circle. But then if I want 0.5, we need double this. So there is a relation between these two. And what I'm going to do is I'm going to copy this parameter, right click, copy parameter, and right click here and paste relative reference. And whatever this value is, I'm just going to divide it by 360. So now it's set to 1, right? If I increase this, so it's 1 divided by this number. Copy, paste relative reference. Sorry, it's 360 divided by this number. It's the inverse of what I just said. So if I increase this, you can see now that the angle is changing, and we're getting more and more curves, and our system functions perfectly. Right, let's go back to the noise. We have that gradient, but remember this gradient, we put an explicit number here, and that's not good because we have to change it to get the gradient to be perfect. So I'm going to copy this, right click, copy parameter, and then dive back in and right click here, paste relative reference, and boom. Now our system is fully dynamic, and I can lower this or increase it, and it's going to work. Right, let's go back in, and right now this is just the color information, so we need to fix and provide the correct UV, and so far we've got 1. So to import a float attribute or access data from SOPs into this point VOP context, I'm going to use a node called bind, and here I'm going to say I want to access the data called curve view, and if I view it in color, you can see this is our data. And so the UV coordinate is, this is going to be U, and this is going to be V. This is going to be the V coordinate. I'm going to use a float 2 vector, and this is going to be the U coordinate, which is the X. This is going to be the V coordinate, which is the Y. And then I'm going to export this as a UV coordinate. I'm going to set the type to vector. I'm going to say it's a UV. The name is UV. And if I look here, middle click, I only have curve U. And if I middle click here, you see we have a UV coordinate now. All right, let's copy some of the noise, which is what we wanted to do really. So let's copy all of this here. And now let's tweak the noise pattern. So it's reversed. So let's tweak it here. And now we have some cool pattern happening using curves, not using points. And yeah, we can flatten the pattern if we wanted to, maybe 0.25. And the next thing from these pictures is we have a perfect circle here, right? So the simplest way, or one of the ways to do this, is by creating an actual circle. Let's create the circle. Let's template it, and let's increase the size and set it to a NURBS sphere, just polygon, and I'm going to increase, polygon. I'm going to increase the division, and I'm going to use a transfer attribute. I want to transfer some data from one side to the other. I want to transfer from this, from this onto this. Okay, I want to transfer the circle information to my points. And if we do that, nothing happens. The data is being moved over, but nothing is happening. So what I want to do is really change the P position. And there is an option for that. If we tick on match P, all these points are now matching the point position here. They're just snapping, right? And if I do to demonstrate, I can show you what is happening. So the points are moving from one location to this location. They're all flattening together there. This is actually a cool pattern. I like it. You guys do something with it. So to limit this transfer function, I'm going to use this distance threshold. And if I start playing with this value, you can see we can limit it. And we can use this blend to make the transition nicer and basically flatten all of this. We can use a circle to remove anything that is inside this. Yeah. All right, let's do one more thing. If you look at the transfer here, the circles are the points. That's what's being used. And because the way the curves are drawn, I want to increase the number of points. And to do that easily without having to change the circle, I'm just going to use a scatter node. And this, actually, I need to change it to an open arc, so it's just a circle. And now we scatter points, and that's what we use to do the transfer. So it's more accurate transfer. And I'm going to use put down a delete node, and turn off enable, go to bounding box, and change it to sphere. And again, we're going to talk more about this, but a quick way is to delete the points that are inside. All right, let's go back and increase our curves to 520, for example. And boom, everything is working, everything is functioning. Let's add another one to the outer layer. And I'm going to copy this same way, and I'm going to merge it here and connect it. And I'm going to increase the size of the second circle to fit the outer layer. And if I didn't like the value used on both, I can just copy this attribute transfer and do it here. And this would be my first inside transfer, and this is my second outer layer transfer. And we can go a bit more aggressive with this. All right. So we made the starting point. We're going to continue working on this in the next video. Thank you for watching, and see you in a bit. Hey guys, welcome back. All right, so next feature I want to do, we can use this one to basically be the bottom layer, and then this upper thick line here, and then we have another layer of wires that are connecting and blending with this. And to be fully honest, we're not gonna make a perfect setup without diving into more complex topics, and I have already prepped a file that I'm gonna clean up a bit. That is a bit advanced, but overall it shouldn't be too hard to understand it. And if you're comfortable with Houdini, I think just going over this should be straightforward, but it is something that we will be able to understand over the next 2 weeks. By week 3, this should all be super easy to explain and understand. It's not that complicated, to be honest, and I will provide this, but we're going to try and recreate the important bits. The main thing, I don't want to dive so deep into this because I don't want to show too much then in the first week, and then everybody feels that Houdini is complicated. So I want to take it step by step. All right, so the next thing is that this layer here. And the way I'm going to do it is I'm going to use a circle, create a circle, or let's just copy this one, and we can make it a bit bigger, maybe 3. Let's template this, and I'm going to use a point VOP. And we can use a Houdini node. Let's try this. We can use an attribute noise and connect this and say the attribute I want to change is P. And now we have noise happening. And I'm going to change the range to be 0 centered, because you can see how it's shifting from the center. And the noise pattern is right now called simplex. We can change it to any of these. And let's try increase the pattern a bit, and let's see how yeah, it's quite noisy with these spikes. Let's try get some of that. Let's increase the number of points, and I think something like this work. We'll use this for now. All right, and I'm going to copy this part. And we have the same curves. I'm going to make it shorter. So basically move it out. Let me template the sphere. And I'm going to move this out like that and make it shorter, maybe 2. Yeah, 2 is enough. Maybe just a bit more. And resample, copy. Maybe not the same number of points. Let's use just 360 for now. We add some noise. Created the U coordinate, and now we have this. And what I'm going to do is I'm going to use an attribute transfer. I'll also flatten it a bit, maybe just 0.5. I'm going to use a transfer attribute, same we did. And I'm going to transfer from this into this. And now if I increase the number of, sorry, if I tick on match points, everything will snap. Let me hide all the other geometries. And if I play with this value, you can see now that the curves are snapping. And we can play with the number of points. Actually, let me do one thing. Let me blend this like that and see how important the points in the first sphere are. So we have this much, it's been distorted. And those are the point goals that are going to be used. So the number of points will decide or control how much clumping we get on these curves. Okay, so let's work on this. Let's lower this value, do something like this. And now this pattern should be lined up. If I template this, it should line up perfectly. And that's how I'm going to do it. Right, let's merge this one with this, so we have both results combined. Cool. Yeah, it is working. All right, so the next thing I want to do is I'm going to convert this into geometry, into polywires, because if you look at it, they're quite thick. There is actual geometry here. So we can use a polywire node. Let's just use a polywire node. And I'm going to increase the number of divisions and make them feel that they are tubes, and lower this maybe to 0.05. And there we go. We have nice curves. Let's go and increase the number of curves here and see how that would affect the result. Yeah, this still works. And I think here what I'm going to do is I'm going to resample the curves and try to make them smooth a bit, because I feel they're just too sharp. So I'm going to resample them, and here I'm going to turn on subdivision, and that will make them a bit smoother. We can also use a smooth node to actually smooth out the curves exactly like that. And now if we merge it together and do a polywire, we'll get this cool shape. All right, so that's one thing, but it's not looking great. I don't like how thick they are here and how thick they are here. I want them to start thick and then thinner out as they get closer to this, or basically blend in. If this is the size goal, I want it to be 2 times bigger here. So how can we do that? Well, we have that curve view. See, we have that great, nice ramp, and we can use that to drive an attribute called p-scale. So let me isolate one curve so we can show this. I'm gonna blast this and delete non-selected. And I'm gonna connect this here. And if we say at p-scale, scale, nothing happens because we don't have this attribute. So I'm gonna use an attribute, create, and call it p-scale. And again, this is by default, it's the attribute that controls the particle size and the size of many things in Houdini. And I just made that attribute and it's equal to 0.1. But instead I want to make it be driven by that curve view attribute. So let's create a point VOP and let's import the color, because that color right now has our curve view, or we can also import the curve view again, and just to be safe. So curve view attribute, and I'm gonna bind export it as p-scale. All right, and now if we take a look at the polywire, it's being driven by the p-scale, but it's linear, it's 0 to 1. So let's divide this by 10 so we can see it, and boom, it's getting thinner and thinner at the end. Now how can we change this so that it has some thickness at the end? Because if I merge it with this geometry being polywired, let's see, 0.01, merge these two, it has to have some thickness, right? Like here, this is quite thick, and then it thins out. So let's increase this to 0.5, maybe something like that. But I don't want this to be 0. So what we can do is we can add a constant, 0.01 plus. This will be the minimum value that the width is going to have. And then if I increase that, you can see it's thickening out this, but also this. It's across the board. It's a linear. We're just adding an offset, basically. All right, let's disable this. Now we have our curves. I think they're too thick. So let's divide them by 15. All right, so now it's too thick. I think we have a lot of curves as well. So let me lower the number to 360 because there's a lot of gaps here. And I'm gonna lower the number of points here as well to create more gaps, maybe increase the transfer. Yeah, increase the transfer, maybe even more gaps. All right, now what we can do is we can convert this into an entire volume, all of it. So what we can do with this is we can make it into a surface. And again, this is going to be talked about in much more details later, but we can use a VDB from Polygon node and convert this into a volume field or an SDF. I'm going to turn on fill interior, and now we have basically a volume made of all of this. And then we can convert this back into a mesh. So VDB convert, and please trust me, we're going to dive into this more and more later. And now we've converted all those individual pieces into a single geometry. Let's increase the resolution of this volume a bit more and lower this. And I think we have a nice setup now. Let's see, we have this layer. I'm going to connect that here just so we can see it. Excuse me. And I'm going to use a polywire as well. And let's see how many points we have. So we have 59, not too much. And let's convert this into actual wires and reduce the size of them so we can see them. Now if we connect that, and let's add this, let's move this layer up because it's always up. Maybe even more because that ring has to be up. So here, this one, I don't think it should be changing up and down a lot. So I'm just gonna put a transform and reduce the size of it. And when I merge it, sorry, here, I need to reduce the size here. And now when I merge it, it should be better. VDB, convert, and now if we combine it, it's up, right? Let's move it down. Obviously not perfect, but I think it's a very good starting point for this. And I really wanted to show how Houdini works in this small example. And then the more advanced setup, I'll document this a bit more, but there's a few more things advanced, like complicated with the attribute transfer and a few of the point VOPs. But again, you don't have to fully understand this yet. And I think overall the features are pretty much the same, except that the noise here is very well connected together. You can see this this pattern here is the same that's been used, and then this transition is much softer and nicer, smoothed out. But overall the concept is pretty much the same. And then we still have to figure out how to do the rounding at the outer layer. And a quick way we can fix that by doing something similar to here. So I'm going to copy attribute transfer and put it here to basically attract all of those at the outer layer as well. And you can see this long wire, I don't like it that much. So what I'm going to do is I'm going to create a null and call this outer layer, and then use that shortcut to do an object merge. Copy it and then place it here, and that's my input. So I don't have to get crisscrossing nodes. Now if we do a polywire, merge VDB and combine, we should have a better shape. Right. One last thing I am going to try and do is something that I notice in the picture is they have this nice curvature, right? They have this nice curvature going down. We don't have that. It's all flat. Let's do it procedurally. And I'm going to create a point VOP and dive inside. Actually, let's create a point. I'm going to create a point to explain something. 0, 0. And right now we have a point at 0, 0. It's hard to see, but there's a point. And I'm going to copy it and move it in space. And I think I've been doing the entire setup upside down. Yeah, the gnomon is pointing down. So we should have been working like this, but it's done now. We'll just flip it at the end. So let's go about this the right way. Okay, so I have a second point. I'm going to connect both of them and create a line between them, all points. Okay, so what this line is, it represents the vector needed to move this point from here to here. And that's what the P position is. That's what P attribute is. If you look at it here, the point 0, actually let's reverse them. Point 1 is here, and it has a vector x, y, and z. That's the point position, p, x, b, y, p, z. And the coordinate of this point is the vector that is required to move this point from here to here. So p is really a vector like anything else, like a normal, like velocity or anything. P is nothing but a vector. So when you think about it this way, if we take a look at all of this, each point is a vector, right? This point here has a vector that moved it from this. And this point has also a vector that moved it this way. And so a vector always has a direction and a magnitude. So if we compute the magnitude of this and the magnitude of that, they're going to be different. Let me show you that. So if I compute the length, which is the magnitude of a vector, and plug it into the color, we're going to get something. If I look at the attribute, you can see it's between 5 and 1.7. All right, let's talk about fit range quickly. So let me delete this. So let's say my data goes between 1, and 10. What we can see in the viewport without it being over bright or super bright can only be between 0 and 1. The things that we can see black and white can only be displayed between 0 and 1. So what we need to do is we need to fit range this. And the new range I want it to be is between 0 and 1, so that I can see it, right? So what we need to do, this is a 10. So what we need to do is we need to use something called fit range. And it does exactly what I just described. Fit range. Yes, that's a fit range. Sorry guys, I used the mice. yeah, fit range. And I'm going to take 0 to 10 and convert it into, fit it into 0 to 1. So basically this will be this, and then 1 will be this. Sorry, the value is 1 to 10, and it's going to be mapped between 0 and 10. That's all we need to do. And so let's do that. Let's put down a fit range, and it expects the in and out. So my min and max, and my new min and max, this value and this value and this value and this value. So my current min and max is 1.7 from that spreadsheet to, sorry, 1.7 to 5. And the output range is 0 to 1, so I can see it. And right there, we got this nice gradient happening. Okay? All right, let's do this. I'm going to I'm going to split the point position. So each point, let me change this to a different color. And each point is inside of grid, right? It's a Cartesian space. So each point, we have a grid here, that is our grid. And then we have a point in space. This point has X, Y, and Z, and that is a vector. And I want to split, I want to access this. Each one of these individuals is a float. I want to access all of them, but only change this Y. I want to add an offset, and then I want to plug all of this. I want to plug all of this back into another vector, X, Y, and Z. So how can we do that? Well, we can take V and split it. So now I have X, Y, and Z. And I'm going to use add constant, or just an add function. And I'm going to leave this for now. I'm not going to add anything. I'm going to plug it back in. So float to vector. I'm going to say my X is the same, my Z is the same, and the Y is different. But I haven't changed it yet. I'm going to plug this into P. Nothing changes. Let's create a constant. This is just a slider. I'm going to plug it into the offset of the Y position. And now if I change it, it's going to move my data up and down. But what if we don't use this? What if we take this and plug it here? And now we're getting this. So why is that? Well, because this is black, it's 0. This is white, it's 1. So Y is changing based on this value. So if we change this 1 to 0, we get this. But what if we change this to -1? We move it down. And let's remove the color. We move this curve down. And we can control how deep we want this to be. But it's not the best, right? So let's expose this min so we can control it outside. But then this I don't like that much, right? So what do we need to do? I'm going to set this back to 0 and 1. And I'm going to visualize it. And I'm going to use a ramp node to change this so that we only have white here and then it disappears quickly. Because if you look at it in the picture, it's just this curve and then it goes away. It's the same, or maybe some height, or maybe it's bulging like this. Yeah, I believe it's bulging. So let's connect this ramp and use a spline. And let's go back up and let's look at the color. And now I'm not changing the height, by the way. I'm going to set this to a smooth curve and move this. And this is the information I want to use to drive my offset. So here I'm going to use this as an add. And now that's what we're getting. But we want to be able to control it. So I'm going to use a multiply node, plug it here, and then expose the second input so we can control it up at the upper level. I'm going to call it height. And let's go back up. And now we have this control called height. And we can also do the reverse like this. Sorry, like this. Push it down. So -0.01. And let's just disconnect the color. I don't want to be distracted by that. And let's look at this. So you can see now we have this nice bulge going down, and we can push it down a bit more. So that's one way of doing it. The other way of doing it is using a soft transform, which is much simpler. And I'm going to use a group node because I need to affect specific points. So I'm going to use a group node, and this I'm going to turn off the base. I'm going to turn on region, set it to points. I'm going to say this is the group called to affect, and it's going to be driven by a sphere, and I'm going to scale the sphere so that it touches those points. I'm going to put down a soft transform node, and here I'm going to say I want to affect only the points that are in the to affect group. And now if I move them up or down, you can see already there's a soft deformation happening that is driven by this radius. So we can have this done using this node, and we select points by hand. All right, so we'll use this one, and then if we do a polywire, you can see now it has that nice curve. And then the last thing I want to do is, I'm gonna reverse all of this, -1 here, and use a reverse node because the normals are now flipped. And I'm gonna use a color node and change the background to black. And here inside this color, I'm gonna use that ramp attribute that is called curve view, and we can change the color to be, it is dark in the center, and then we'll use a blue tint like this, make it a darker blue at the outer ring. And see, because we deformed the curves quite a bit, they are not respecting this curve view. It has changed, so it's best to drive it based on the distance, like I created this new mask here, like this one that we created based on the distance. So this is a better control, but we'll use this for now. It's fine. And then this one, I'll just give it a constant color because after we did this UV processing, the curve view is not going to propagate. So we'll just use a constant color and make it a dark brown, something like that, just for illustration. And let's move this up a bit, 0.25. So it's above this layer, too much. All right, so that's our initial eye. And again, like I said, I'll provide the bit more complex version, but overall this is what I wanted to explain, and I think we've covered a lot of nodes this time. Hopefully you guys are comfortable recreating this from scratch, and let me know how it goes. Thank you for watching. See you in a bit. Hey guys, and welcome again. I got a request from one of our students to how to create an effect like this where you have curves that are swinging in an abstract way. And I put this setup quickly, and I'm going to use it to show a few things about Houdini and how to make a play blast, set up some light and tweak the settings so we can get some nice viewport captures. And the setup is fairly simple. It's done using Vellum, and also going to use this to explain how caching works in Houdini. So the first thing that we did, or I did, is I started off with a circle that I set it to an open arc, and then I reduced or deducted 10 from each angle so that I have a small opening. And the idea is I want to have these curves that I'm going to swing back and forth to create that ripple and rotating movement. And the idea is to basically create this geometry and then hold these points and then spin them and let the curves follow along. How it's done? Well, I created this, and I know I needed a curve to be able to pin these points. So I grouped the start and end. So I grouped by hand basically the point number 0, and this is the end point number 36 because the curve has 36 points. And then I copied it to get some internal structure using a copy node exactly like this. So copy and transform, and then you can scale it down like that, increase the number of copies, and then I can move the pivot, which is located here, to change how the points are being, how the circles are being scaled to something like this. Then I'm do a copy to make a circle off of this, and the curve, the original circle is already away from the center, and we can just duplicate this maybe 100 times, and then increase the copy number and do something like this. So now we have a full circle of circles that have circles in them. All right, the next thing is I want to select those points, the top and the root, the start and end, and basically have them spin, have them go back and forth like this. And to do that, I use the sine function. And what the sine function does is, given a float that is always going up, which is time is always going up, the sine function will return a curve that looks like this. It actually goes in the negative, so this is 0. So the sine function will give us something like this. And I'm using that to drive the rotation. So let's put down a transform, and if I animate this or just middle drag this, you can see that it's moving. If I put $F and move the timeline, you can see it's spinning, but I want it to spin back and forth. So I'm going to say sine of $frame, and that's going to give me something between -1 and 1. So if I click here, you can see it starts at 0.10 because the frame is not 0. And then if I keep going, you see it's going to go back to 1, and then it's going to go to -1. So it bounces between the two. And to increase this result, I can just say multiply by 50. So instead of -1 to 1, it's going to go between 1 and 1. You can see how it's spinning back and forth. And if we multiply, or if we wanted to go faster, we can just multiply $frame by 10, and now the result is 10 times faster. You can see the pivot there is spinning back and forth. All right, next is we're going to use vellum. So this is beyond the scope of week 1, but we can just, quickly plug in 2 nodes, basically a vellum cloth node. It's called cloth, but it's set to use hair, and you don't have to change anything. You can just create a vellum cloth here, set it to hair, connect it here, and then under the pin to animation, I want to pin the start and end to match the animation. That's basically all we have to do. And then inside the vellum solver, and this is for cloth and hair, I'm going to connect this, and that's it. I don't need to change anything else. And now if you hit play, you can see the curves are swinging back and forth. Now there's gravity that's pushing everything down. I'm going to go under forces and set gravity to 0. And now if I play, they're not going to fall anymore, and they're just going to keep swinging back and forth. Awesome. So the next thing I added is I wanted to add some collision, just so that the curves don't swing back in. And what I've done is I created a torus, and I clipped it like that. And then I peaked the geometry to add some padding. So this will just move the geometry along the normals. I extruded all of it. So poly extrude here, and just extruded the entire geometry, and then turn output back on. And then I extruded again these top. So I changed the selection using the 4 key, and then select the face, hold Shift A, and then click to do the loop selection. So Shift A here, and then hit Tab, extrude, and then I'm going to turn on global transform because I don't want to use the normals. Change it to global and just move this up. And now I have like something to collide with everywhere. And I plug this here in the 4th input. And now if we hit play, you can see that the curves are no longer going inside, and they're colliding with the outer layer as well. Very, very simple. Don't need to overcomplicate things. Put the vellum hair, a vellum cloth, set it to hair, and vellum start, and pin your start and end point. All right. Next thing is the file cache. So this is this is updated in Houdini 19. And to cast the result, this is where it's coming from. You can see it's saying at the bottom vellum geometry. I'm going to connect it to my file cache. I want to write this to disk. By default, you don't have to change. Anything. You can increase. It has a numbering feature. So let me delete this. I'm going to say I want to cache 50 frames. You can hit save to cache, and it's writing here, and it's done. And now if I go back, it's playing from disk up to 50 frames, and then it disappears because there's no more cache. I can change the version and save again. And now I've changed the version, and I can go back between both of them. So this is loading in different version. To see where the path is pointing to, you can see it. You can go to advanced, and this is where the file is actually located. Now, see this, where is it? Why is it, this was not the case. Let me create a file cache again. So this, by default, is pointing to the hip name.os. So when you create a cache, the hip name will resolve to the file name. The OS will resolve to the actual node name. So the construction is going to be file name.file cache. When you hit save, that dynamic part is going to be flattened into the actual food path. The reason for this, so if you version up the file name, the read node is not going to break. That's why this expression is flattened out into an actual string so that it loads in the correct data. But when you drop it in the first time, it comes in with this expression. You can keep this path. This is going to give you a unique name, and it's not going to overwrite. And because it's driven by this name, every time you create a cache, it's going to be safe. So the way I would do it is, I personally don't like the hip name because I know which version I use. So I'm just going to use the $hip, and I have a different location. So let's say I have my mount folder and NAS, and then cache, for example, and then all that goes into Geo. So this is where I cache my data, for example, not specific to the project, but to all my Houdini work. This is my caching data. You can use $hip. It's going to be, $hip refers to the folder where your file is. So that is going to be like that up until here. And if you middle click on any expression, Houdini will evaluate it and give you the result. This is just a preview. See this dotted line means it's just a preview. You're not changing anything. This is the frame range, and yeah, that's pretty much it about this. You can be explicit and specify exactly this, which is the old file cache, but I like this one. And then here I say vellum wires, and then I use the version number, and then you can version up this one. And then if you want to turn that off, you can do that as well, but you will be overriding the files. So this is how pretty much all the file caching works in Houdini. You have a sim, you import the data, and you save it to disk so you don't have to sim it multiple times. And then here I cached out the sim already. So let me see. And I have there's this glitch. I bet it's fixed in the newer Houdini version, but sometimes the viewer will ghost an element and it's not gonna go away. So I just closed the viewer and create it again. And let me change the background to light so we get this nice gradient. And the next thing is I'm putting a resample to add more points to the curve so that when I use a polywire, I get some nice details. And then here you can see all the curves. Now I added a twist node because I wanted to have more deformation. And this is basically a bend and twist node that has all the features together in one place. And so if you create a twist, it's basically the bend node with a twist on and the bend off. If you create a bend node, it's the same, but the bend is on and the twist is off. So it's combined together. And let's create a twist node. And the first thing we need to specify is the capture direction. You can select the node and hit enter in the viewport, and you'll see the direction of the twist. That's the up axis. So here I'm going to change it to Y. So it's pointing up, and then the pivot needs to be below because our circles are below the 0, 0. So I'm going to say -1, -0.25, just to cover this. And then the height, we can cover just enough coverage for this. And now if we spin or twist, it's going to twist our geometry. And it's not going to add collision. I know this is weird, but it's not going to make it collide because it's moving all the data together. And so if I do the polywire after this, there's no collision added. Actually, let's increase set this to 0.05 and this to 2. Sorry, not the length, this one, to make sure that all my data is being captured. And now the twist is working. So you can see on and off, just to add something. All right, so that's the caching. And then here, Houdini 19 has a really good viewport. They improved a lot of things. So I'm going to create a grid and move it down. And I'm going to create a light. And by default, I'm going to change it to match the default settings. And I'm going to change this to a sphere. It's a light. And I'm going to make it smaller and move it up. And we can get a lot of cool stuff in the viewport. So the first thing is I'm going to turn on lighting. So now we can see the result or the illumination from the light. And we can also turn on shadows by clicking this one, high quality shading. And then if you right click, you can choose different types. So point shadow, area shadows, anti-aliased shadows. And then you can also add ambient occlusion to the scene. You can add reflection, which we don't have in the shader. You can add a fog. Yeah, the fog is added. We have to change it. And then you can add depth of field as well, which is very, very cool. Let me look through the camera. Let's create a new camera. And for the camera, I'm going to select it and hold the lock and then move the camera. And you can see now we have depth of field in the viewport. And if you go under the focus or the focus distance, we can change this. You can see it's changing. Yeah, it's very sensitive, and the scene scale is very small. But yeah, you can get some cool viewport. And then for the fog, I'm going to press D and go to fog. And you see here, that's the background. That's the color of the fog. And I'm going to increase the density. See if I can get it to be in my shot. Yeah, I think my scene is very small. That's why. Too much. Yeah, see if we're reaching it now. So you can get some nice OpenGL captures now with Houdini. And then under the shadows or lights, you can turn on, you can increase the quality of the shadows. You can increase the quality of the ambient occlusion here. And then this one for the shadows, let's set it to 12 and 12. You move the camera here. And I'm going to turn off the fog so we can see better the result. And also turn off ambient occlusion and depth of field. I want to see if we can improve this. That should be it. Yeah, it's not improving much. Let's try. Yeah, I think this is helping. I haven't tested it, to be honest. But yeah, you can get some nice shadows now, and all of it is real time. So you can move the light and get nice interaction. And then if you look through the camera, and let's lower the amplitude or the intensity of this light. And let's create another one and change the color to have a different tone and change it to a distant light. I just want to have some coverage and lower the intensity to 0.05 just to have some fill light in the scene. And the light controller is visible, so I'm just going to hide it like this by disabling the blue dot. And then to make a screen capture or play blast, you can right click and select the range, let's say 100. And under flipbook, you can specify the resolution. By default, it would be like this. Make sure that you have a something divisible by 2, and otherwise you're not going to be able to convert it into a movie clip and a movie file. So you can specify the resolution here to make sure that that doesn't happen. And then you can turn crop view output. So that's basically this grayed out area that you see. And yeah, you can remove that. So we'll do that. And let's set it 1280 by 720, and then hit play, hit start, and it's going to start caching the viewport, and it will open up this the separate tab called mplay. This is where you view images in Houdini. Actually, it crashed the image in this case, but that's fine. And then if you install something called FFmpeg, I don't know how on Windows it works, but I believe you can install QuickTime or FFmpeg. Just Google it and you should be able to do it. You'll find this option to convert this into a clip. So you can do, yeah, you can export it into a MP4 file and make sure it's MPEG video HQ for high quality. And that's really it. That's the only setting. And make sure this number is divisible by 2, otherwise you get an error. No sound, and then you hit save, and it will convert this into an MP4 clip. You can also save the sequence to disk if you want that. All right, that's really it for this quick sim here. I used the scene to explain a few other things, but basically for the vellum, for now, all you have to worry about is this node and then this node. And later we're going to dive more into how all of this works under the hood and how to properly use it. Thank you so much for watching, and talk to you soon. Bye-bye. So let's start diving into the corridor scene, and I'm going to show the final result, and then we're going to break it down into smaller sections. So this is the final model, and it's a combination of multiple pieces that are grouped together. And the main one that we're going to be creating is this interior scene. This is how the chase tunnel corridor scene, chase tunnel scene was built. So that's going to be part 2. So this is obviously the final result. I make the geometry because I want to explain the parts that combines this. The element that was added extra is this one. And yeah, we're going to talk about this as in part 2. And this is the block we're going to create. And what I've done is I've mirrored it on this side, and then I mirrored it again along this axis here, and then I'm duplicating this multiple times and offsetting it. And this is our corridor. So when looking at something like this, it looks quite complex, but it's really simple when you break it down into smaller sections. And it's going to be pretty straightforward to recreate, and also going to learn tons of cool tips and tricks about procedural modelings in Houdini. All right, so let's see how we can create this awesome block. Okay, let's get started. So the main aspect, the main visual criteria that we are going to need is these type of shapes, where you have continuous shape and then something being subtracted from it. And you can see this everywhere. We have these specific angles like 45 degree or 60 degree, and then they go a straight line. And so all these shapes are built based on 45 degrees and 60 degrees or 90 degrees. And generally when you follow these rules, you're gonna end up with something that looks mechanical and it looks sci-fi. So let's try to create a grid. I have this awesome viewport thing that's showing the shortcuts. I'm gonna keep this on for this week, and if you watch closely, you're gonna be able to learn the shortcuts, even though I don't mention them. In this case, I pressed space F to zoom in. Okay, let's go and change the viewport, and let's leave this 10. It's okay. I'm gonna change this to 2 and 2. I only need a flat box, and let's put a bevel node, and with this bevel I'm going to select a point right click here and select the point and hit enter. And let's increase the distance. You can see we're getting a cut now. So I'm gonna copy this node and I'm gonna run it on all the points. And let's do it again. So let's put down a poly bevel node, connected. I'm not gonna change anything, just gonna increase the distance. And I'm gonna change this to chamfer and points. So if we set these parameters, we're gonna end up chamfering the corners or the points at in the corners. And I can change this to be something like this. We can also do it again, and it will keep on subdividing or, you know, doing these corner beveling feature. Now let's extrude this using a poly extrude node. I'm going to select the node, hop over to the viewport and hit enter and push this up. And I'm going to turn on output back. So let's look at this. By default, output back is always off. I'm going to turn it on, and now I have a full geometry. I'm going to transform this down. I'll explain in a second what I'm trying to achieve here. And I'm going to template this to show the polygon or the grid that we made. And what I want to do is I want to move this in a way that it intersects with that geometry in a meaningful way. And I think we need to do some editing. So I want this geometry to be inside. So I changed the mode to edit. And you have to make sure that you don't have anything being displayed, otherwise it's going to add a merge node. And I'm going to select the points here. In the viewport, press the T key and then move this. Same thing here, hit the T key and then move it. And template the grid. And I'm trying to get the shape to be to intersect with this one. Let's try to move this back a bit. And we're gonna boolean the two shapes. So I'm gonna boolean the grid with this. And right there, we've got an interesting shape already. So I'm gonna create another transform node, and I'm gonna template this one. And this transform is connected to this shape, and we can view it. Make sure if you see the gimbal in a different location, it's pointing to a different node. You have to hit enter again to get the pivot to show up again. And let's move this and maybe scale it down, and let's move it here. And let's do a boolean again. I'm gonna copy this, paste it. I want to boolean the result that we've got with this new geometry. So now we have this shape, and it's all procedural. Obviously we can move all of this in any way we want. I'm going to do one more, and let's rotate it this time. And because we're using the same shape, the same language, it's going to feel natural. And let's do this again. We can obviously combine the shapes and do a single boolean, but this also works. And let's connect it here so we get all the shapes that we want. And let's copy one of these poly bevel, and let's connect it again to the end result and see how that looks. So we're beveling all the shapes, which is not working. And I'm only interested in changing a couple of the angles. So I'm going to click this arrow button here and select this point that is super flat, that is 90 degree, and this point, and hit enter. And I'm going to increase this to something like this. Let's create a extrude node, connect this, and move it up. Take on output back. And now we have some interesting sci-fi looking geometry. Took a couple of nodes, but it's all procedural, and we can optimize some of this if we want. I believe we can merge, for example, these two nodes like I mentioned, and copy this and this. So here the result should be the same. We can combine multiple geometry and do one boolean instead of individual ones. Okay, let's put down a transform node. Maybe let's extrude this a bit, set it to 1. So see how the transform is not in the center. I'm going to click on move centroid to origin, And this is going to move the piece to the location, but I don't need that. I just need to change the pivot. So what I'm going to do is I'm going to click Control 0, and that will put the geometry back, and see the pivot now changed and it went to the centroid of the geometry. So let's template this, and what I want to do is combine or move this to create some interesting intersection. And let's move it up, and we're going to do a 3D boolean this time, not 2D. So let's move this, let's copy this node again, and let's change the geometry scale, and let's rotate it like this. And let's create a boolean node and merge these two together. And let's combine, do a boolean against the original geometry, which is this one. So you can see this one here, and then these two, they're intersecting. I can probably move them down a bit more. And let's see what we get. So this is the result of that 3D boolean geometry operation that we did. Cool. So we can continue in this path, and we can always change the geometry. We can move it, and it's all procedurally moving and changing. I want to do one more thing here. I'm going to copy this node and merge it again and move it down to create this interesting layering effect. And maybe rotate it like this. Yep. And you can see we're getting some cool cavities, cool intersections. And I think this piece is ready now. So let's save the scene, and let's make it more complex. And let's do that trick again. Move to centroid and then zero this out. And let's copy this node. So we have the first transform. We'll leave it there. It's okay. And let's rotate this. And Control Shift, obviously. Click will show the node in the viewport. So let's see how we can make this look more interesting. Again, I'm just trying some stuff live. I have not done this previously, and I just wanted to illustrate how this works. Okay, something like that. And let's copy this node one more time. And actually, let's merge all of them. And let's template and untemplate one node, and then everything else will get resolved. Like all these purple and pink rectangle squares will get removed, so nothing else is visible in the viewport. Okay, second copy. Let's move it up here and maybe rotate it. Yeah, this is cool. Yep. I'm trying to move them up and down to get more height variation. There's some details I like. I want to show a cool trick. So let's create a grid. And let's move it here. Just to fill in this gap. I'm going to increase this number. I'm going to increase, no, just this. And let's look at the result. Let's create a extrude node. And let's display flat wireframe shaded. I want to see the wires. And I'm going to change it to individual elements. And I'm going to lower the inset or move it up. And you can see we're getting these cool shapes. I'm going to tick on uncheck output front. And now we're only getting the inset result. So what is different basically? And this gives us this grid layout shape very, very quickly. And that's what I was trying to create. So I'm going to extrude this up to give it some thickness. And in many cases when you extrude, well, this is a perfect geometry, but in many cases you get these weird vertices that spawn off and go to the infinite. And what we can do is we can remove the normal based extrusion and just do it on XYZ. So I set the distance to 0 and I set transform extrude front. I'm going to change it to global and then move this up. Still displaying, but this is not the issue I was talking about. Everything is good here. And I'm going to merge this with the existing geometry. Actually, let's put down another merge node. And now we have this grid structure inside, and let's move it up. We can make it thicker, something like this, and let's move it up there. Maybe add more. And we don't need obviously all this extra. I can just squeeze it in and only keep the data I need. This works. So this element is very similar to this one. So you can see there's a ground element here, and that's the element we're trying to create something similar or show the technique. So we can start with a simple grid and then create some beveling and combine the shapes to create some sci-fi looking geometry. And then by combining all of this, we can create a nice intersecting geometry that has sci-fi design. I'm gonna refine this a bit. I'm gonna do a Boolean operation, and I'll explain why this in a second. So I'm gonna take this one, and let's intersect them. Let's see what happens when we start combining both of them. So this is very, very interesting shape. And let's keep that for a second and create a peak node on this one. What the peak does is going to take the normal of the geometry and use that as a vector to push the points. We can make something shrink along the vertices. Now when it comes to sci-fi, this is very dangerous because the angle generally are very sensitive, and this node is going to try to mess with that. But what we can get is if I display the Boolean result in this new one, we're going to see a gap now. So let's merge it so we can have a nice display, and let's turn this off. So if I combine this two, you can see, yeah, you can see we have a gap, but we're starting to get the geometry messy now. And maybe we can scale it the y-axis just a touch. Now we have some really cool intersecting geometry, and they're both separate. Like if we needed some destruction or anything, we're gonna have perfect geometry to work with. So that's one thing. The other thing I wanted to do is run Boolean on everything to remove any intersection, and I'm gonna do it here. So I have all this together, just gonna Boolean this single node, and gonna go to shatter. And now it's working. So you can see by having this single node, it's intersecting individual pieces and removing any overlaps. So see, this one is no longer intersecting with this. And that's very, very cool because we can start messing around, and we will get a lot of interesting details with this technique as well. Double click on the geometry and then T to move the geometry. You can see the gimbal is pointing in a weird direction. I'm gonna right click on it, click on align handle world, and I'm gonna move it down a bit just to shift the geometry and try to access that new pieces that resulted from these intersections. Now, obviously we're gonna get some intersecting geometry at the end, but that's perfectly fine. So just looking where we can find them. I believe there's one here. Yeah, I think that's it. Oh, there's one here. So I'm gonna select it and move it up. I think there's another one here. Yep. Let's move this inside and out. And now we have some amazing details. I love these height variation. And let's go back to that grid that we did. I'm gonna copy I'm going to copy the grid, select all the nodes, Control C, Control V, and copy the grid. Yeah, I definitely like this. And let's try to copy this now and create some sort of ground geometry. So copy and transform, and I'm gonna select the copy node, hit enter in the viewport, and then move along the x-axis. Yeah, you can leave some gaps here and fill them later with a different geometry. And let's increase this to 4 copies. And I think the height variation is too much now. So let's just put down a transform node and scale it by 50%, maybe more, because we just want these surface details. Yeah, that's very, very cool shapes. And let's mirror this one along the z-axis. And we can either do something like this or this way. I like this way. And there we have some really cool stuff happening. So let's copy this grid again, and I want to fill these blocks. And what we can do is, because we know how it's looking here, I can just transform this one, copy and plug it again. And let's do that trick again. Move to centroid, push it back, put it back, and then because it's happening in the center, I'm just going to move it into one side. And let's move it down. And perfect. So now we've created a very cool sci-fi looking shape. And this is one of the ways to see. We did this. I'm going to copy it again. And actually, I'm not going to copy. I'm just going to go back to the original shape. I'm going to put down a mirror node. And I'm going to mirror it along the z-axis. And let's move it inside. Like this. And let's move this grid here and scale it. Again, I broke the other version that we just tweaked together, but that's fine. I'm gonna scale it and use it there. And now let's copy this copy node and transform all of this, and also that transform the flattening node. So we have a different pattern now. All right, let's continue exploring other methods in the next video. Thank you for watching. See you in a bit. Hello everyone, and welcome back. So we've managed to create this or this, whichever you like. And what I want to do now is I want to quickly show how to create a cover or ground elements like this one. You see this shape here. So I'm gonna go back to this, and this is the one in mind, or the other one is fine. So I want something that covers this. We can place it, and it's gonna be somewhat like this. What I'm gonna do is I'm gonna try to find a shape that I like from this. And I'm gonna pick this one. I can't explain exactly what I have in mind unless you guys watch me do it. So I'm gonna isolate this piece, and I'm gonna transfer it. Transform it to the center, and let's use an extrude node, and the image or the idea is going to become clear once I make some progress on this. Let's extrude it a bit more. Okay, I'm going to use a node called clip to clip the geometry and aim it along the z-axis, and now we're deleting everything above this, so I'm gonna invert it. I'm gonna clip everything below here. Okay, so what I'm gonna do next is I'm gonna mirror this one, and let's transform it because now it's flat on the ground. I want to transform it 90 degrees. Let's extrude this and give it some thickness. So poly extrude. I'm going to use a global transform, and tick on output back. So now we have a nice block that we can copy and place over. Now we've extruded this profile and got this shape. I want to make it more interesting from the top. So we want to make the silhouette of this more interesting, as well as create cavities and intersection to add more details in the center. So let's go back. I'm going to use the same geometry because I think it has a lot of potential, and let's use the transformed one. I'm going to mirror this, and again I'm doing this live, so I don't know what's gonna end up happening. Let's try something like this. Yeah, I think this is good, and let's fix it. Let's put down a clip node and clip the geometry along the z-axis and top to bottom, and then I'm gonna move it here and then move this up. And I'm gonna make sure that the points are being combined together. So let's move this closer and increase this. Okay, so now I have this cool shape. I'm gonna mirror this one more time along the z-axis, no, along the x-axis, and let's select the mirror node and hit enter. The y-axis, oh no, sorry. Okay, I'm gonna mirror this along the z-axis, and let's leave a gap. I think that's gonna be interesting. Let's scale it up in an interesting way. So I'm gonna go back to this. We did the clip here. Sorry, the mirror. After the clip, I'm gonna select the points, these points. I'm gonna template this, the end result. Hit enter. No, we have to do it again. So select the points. Press T. I got an edit node here. I'm gonna template the end result. And now I can operate on my node and see the result right away. So we have access to scale it to fit the environment we need. Now to make this geometry more efficient, I'm gonna go to this one and put down a divide node. Uncheck convex polygon, and I'm trying to remove this. And I'm gonna turn on remove shared edges. What this does, it's gonna give me the necessary polygons that forms the outline. So anything inside will be removed. Template this, and let's extrude and transform this. So let's do two things. So select this one, hit enter, and now we can move it. And I'm gonna go back to this and move it up, something like that. Okay, let's extrude this and output back, and I'm gonna use global transform and extrude all of this, and let's move it down a bit. And now let's boolean both of them. And intersect all the geometry. And we have this this shape in the center. I think maybe this is too big. Yeah, I think something like this would work. Okay, now I need the difference between the two. So I'm gonna copy this again. I'm gonna say, instead of subtract, I'm gonna say intersect. And now I've got the difference basically, and this is something I need because I plan to combine it again, but what I'm looking for is to introduce more details. So I'm gonna merge both of them and then move this geometry a bit and convert it into something interesting. So let's go back to this one. And let's create a grid. And I'll explain why the grid. So let's increase the size to 12 and 12, and let's set this to 100 and 100. Okay, and what I'm going to do is I'm going to use a ray node. Let's move this grid up. What the ray node does, it allows to project geometry onto take one geometry and project it along a vector, and once it intersects with a second geometry, that's the new position that's going to use. So right now it's creating this mess, and I'm going to change it to vector and delete this vector, and this is the grid and this is the bottom geometry. I want to project the grid, actually I want to project the grid onto this one only, and let's go -1 and show turn off show guide geometry, and I need to inverse this, so Shift R, and now we have the grid projected onto the geometry and it follows the curvature. Now obviously it's outside, and what we need to do is we need to subtract and only keep the data inside this area, which is this one. So I'm gonna use the same thing. Let's transform it here, transform this geometry so that we make sure it intersects with the grid, scale it up, and then let's boolean these two, and now I'm gonna set it to intersect so the grid is only there. Let's see, so the first input is a surface, we have to specify that, and now it's correct, and now if we project it, it's gonna overlap perfectly with the geometry. Now let's see why we're getting this. Let's see where that's coming from. Yeah, I guess there's no projection area for yeah, there's no projection. Look, this is empty, so let's fix it. Let's create a null so we don't mess with our result, and let's select these two, actually these four. Push the R button for transform, sorry, the E button for scale, or R or T. Either of them is going to create an edit node. And let's scale this negatively, maybe all the way, because we don't care at this point, we just need it for projection. And now if I do array, everything flattens and intersects correctly. So let's go back to this and increase it more, so maybe 240 and 240. And let's put down a extrude node. Okay, let's do the same trick to get the outline. So turn off, let's leave it for now. Let's scale it down and change this to individual elements and increase the inset this way. Yeah, something like this. It's gonna be tricky, but we'll go with this one for now. And let's extrude it, give it some volume. And global and up. And let's turn output back on. Okay, cool. So we have this grid silhouette or a grid layer now, and let's try to combine it with the rest. So we have this, and I'm planning to use this grid on top. So let's merge all of it, and let's see how much intersection we have. Cool. I don't like this this part here. I'm just gonna delete it for now. And then there's one more thing I want to do is I don't like how sharp these corners are, so I'm gonna create a box and try to fix that. And this box, I'm gonna actually connect the result, this result, into the box. The size of the box will match the geometry, the incoming geometry. Let's scale it up along the y-axis, and let's select 4 edges by pushing 3 on the keyboard. I'm going to select 4 edges and I'm going to bevel them. So hit tab, poly bevel, and let's increase the distance. And let me template this one. Yeah, so this is how I want to intersect them. Maybe increase the poly bevel, something like this, and let's put down a boolean. Okay, let's reverse the result. Now we're getting the outside. I'm gonna set it to intersect, and now we're cutting our incoming geometry with the outside. Now let's connect this, and now we have a more interesting shape that we can duplicate. Obviously I want to add another layer to on top of all of this, but I think you guys got understood the what I'm trying to achieve here. So let's put down a null and call this out ground element, for example. I'm gonna hit a shortcut to create an object merge. I'm gonna copy this, Control C, and let's go back to here. So let's create a null. Let's hold the Alt key and then drag. That will create a dot. Okay, so I want to merge between the environment and this. Actually, let's merge with this one. Yep. And let's put down a transform, because this one, this element was done in a different orientation, different scale. So we need to fix that. Let's rotate it, move it to centroid, and move it up, potentially scale it down. And let's move it down. Okay, now it's combined. Let's copy and see what we get. Okay, so this element here, the ground element, is not enough, does not have enough coverage. So I'm going to move it to up until this point, and then put down another copy node, copy and transform, and then move this and make a few duplicates of it. 4 maybe, yeah, let's try 3, and we have to find the right balance to make the gaps between all the pieces the same. And then if we fill it with another layer, like either a flat plane or some sort of grid or some sort of structure to flatten this out, but that's the idea I was trying to get at. Alright, next video we're going to use the different method which I mentioned previously, but I wanted to do this first. Thank you for watching and see you in a bit. Hey guys, and welcome back. So one way to generate geometry in Houdini is to use a black and white image and use that information to create flat polygons of respects the silhouette from those images. And a great example for that would be to Google some sci-fi black and white shapes, and this is the one we've used here. So we're going to save this to disk. So let's create a trace node. This is the node we can use to read in textures, and by default it's pointing to this circle image. And I'm gonna use the image we downloaded from the internet, just save it to disk and then plug it in there. And this is what we get. It's generating polygons. So these polygons are not currently usable, and we need it to only be filling these areas. Let's go to the filter and tick on remove borders, and this right away will delete anything outside where the pixels are. I prefer to use something like this. And let's turn on resample. So let's display the number of points. If I don't have resample on, you can see we're getting different points, and I'm just gonna turn it on and set it to 1. This will give us a more unified shapes. I'm also going to turn on smooth shapes, and this will optimize the points so that the algorithm or the trace node only places them where there's meaningful corners or where we need them. I'm gonna set this to 2 to be more forgiving, and that's it. Like we were building some stuff here. or this one. And you can see we're very close to some of these designs already. But let's use this one. So let me grab one shape. I'm going to select this one and blast it. Delete non-selected. And I'm going to transform it to the center and also transform it so that it faces up. And I want to create another ground element. So let's extrude this and give it some volume. And I'm going to create a box. I'm going to scale it so that it fits around this geometry with some padding like this. Fit it so that it's smaller. Actually, let's extrude this more. Yep. Something like this. And I'm going to intersect both. So I need the inverse basically. Let's put down a Boolean node, intersect this with this, and now we have a cutout. This is what I'm looking for. Let's scale this down. It's too thick. Let's grab another shape from this geometry. Let's put down a blast node, copy this, and let's pick another shape. Maybe this one. And let's copy the, I'll drag this, and then just hit move to centroid again, and that will place it nearby this. So let's display the result and copy paste the extrude as well, maybe not this high because I plan to keep this inside, and let's merge both. Yeah, and that's what I'm looking for. So let's create a copy of this. I'm gonna keep it, I'm gonna transform this one and plug it in, and now I can rotate this one. If I hold the control button, left control button, and drag, it will move every 45 degrees. And this is very, very important because when working in this topic or the sci-fi topic, angles and cuts are very crucial to the visual. So we have to make sure that we're not ruining those aspects. And let's copy it one more time and plug it in. And let's rotate it. Let's place it here. Now it's similar to that one. Let's rotate it one more time and let's try to find a more interesting placement for it. Yeah, something like this. Right, let's move it down so we get more height variation. And now I'm going to create more details on the surface. So let's put down a box. Let's just copy this one, hold the left Alt button and drag. No, just Alt and drag. It will make a copy of the geometry. And I'm going to scale this box down and move it up and make it bigger, touch bigger. And let's give it some division. So let me take a look at this geometry. Let's try 6 and let's template this. And I'm going to select, change this to points and select 2 points and move them up, move them out. I just wanted to get this a nice curvature. Yeah, the angle is not too much, but it's gonna look cool. So let's copy, let's just put down a merge node. And I want this and another transform. I want to make another copy, but of the original. So select the transform node, hit enter in the viewport and move this. And then same thing, I'll drag and then connect this here. And I'm going to make another copy here. So this is the shape that we have. This one all the way here. Yep, let's try this. And now I'm gonna use this part and Boolean the result out. Subtract the result of this from this. And now it's cutting through all the way. That's not the goal. I wanna just make a indentation in this to create some cool patterns on this side. And then let's merge this one here. Yeah, I feel this box entirely is thick. I'm just gonna scale it down and move everything, pack everything closer. So move this here, and maybe add another copy. Maybe scale it a bit. Yeah, something like that. Cool. Let's add some details to this part here, maybe this part here, and I'm gonna duplicate this box, set it to 2, 2, and 2, and I'm gonna make it smaller, something like this, and let's move it here. Gonna put down a copy node, copy and transform. Copy this and move it. Maybe make it even smaller. And let's increase the number of copies. And let's boolean this result from whichever counterpart, whichever it's intersecting with. So this one, boolean this from this. Now we have some nice like a air or ventilation section, and yeah, this is very sci-fi looking. And let's try to improve on this. I'm gonna select all of this geometry and put down a bound node, and this is gonna give me a box that encompasses all the geometry, matches exactly, and I'm gonna merge it with this geometry, but move it up. And then scale it. So we have this padding. I'm gonna increase the padding a touch. That's too much. Like this, and same thing here. And let's boolean with this one. And now we have this cool indentation and then the geometry. Okay, let's add something here as well. Let's put down a transform node first of all, and let's transform all of this here. It's too big. Okay, let's see. So move it to centroid. I'm gonna scale it down, transform it back, and let's template this result and move it again. So something like this. But now I don't want this to be square, so I'm gonna clip it. Just put down a clip node, and this is pointing in the Z direction, and this delete non-selected. And now we have clipped the geometry there, but it's all open shapes. It has to be watertight. So I'm gonna put down a polyfill node, and boom, it's gonna find out the openings and close them automatically. So let's combine this with the geometry again, and just do one operation. Hopefully it's gonna work. This may not work. We have that yeah, because of the clip. So let's fix it. Let's go here. I'm gonna hand select this polygon, press the T button on the viewport, and then move it. Okay, cool. Let's try to go back here, and so let's try maybe just on this. No, actually, let's try it on both. And I'm gonna select this one and this one. Put down a bevel node, polybevel, only being applied to this geometry. And I'm gonna chamfer or round all the corners. That's already too much, so 0.01, too much. Our scale, the scene scale, is too small, but that was not, it's not a problem for now. So let's increase this to 4 and take a look. And now we have the inverse shape. You can see it's no longer just a flat section. We have some cool connection there. Let's continue. I have some big areas here. So let's just copy this entire section as it is and try to move it somewhere else. maybe we can get it to work on this one. No, it's not gonna work on this one unless we do some hand editing, which I'm very much against, but in this instance I'm gonna do that. So let me template the goal geometry, and I'm going to select the polygons, these ones. Gonna hit enter. Oh, sorry, let me remove the template because sometimes Houdini gets confused. Let's put down a transform node, and now we're only going to affect this. And let's template the goal geometry and try to place this in an interesting way. And let's see what happens. Okay, so we have all this geometry. I'm gonna combine this new addition and still try to push the Boolean node, and then if it fails we can start fixing it. Okay, cool. So there's one more thing I really like to add. I'm not sure if I can, but I want to make a indentation in all of this. So let me find where this geometry is coming from. So we have this one here, and remember that we did some hand picking, some hand selection on some of the polygons. If I change the topology, everything will have to be fixed. That's why it's not really a good idea to start hand picking stuff. But let's see, maybe we can add it without making a huge mess. Let's put down a peak node and peak this geometry a tiny bit. Yeah. And then let's do a Boolean again. So this is the result, and let's do another Boolean again with this. And you can see it, we're getting another intersection or another clip of the geometry. I'm gonna move the second one, same we did with the vent bending. I'm gonna move this down a bit. There we go. And we got a nice intersection now. And we can also try something bold. This geometry is not ideal, but let's give it a try. Let's put down a bevel node, and let's set this to 0.001, and let's turn on exclusion. Let's turn on exclusion and say ignore flat edges, and try to only get it to work on this part. Let's change it to round, or the default is round. Let's increase it to 3. Yeah, it's not working because this this plane here is not, it's a n-gon, so Houdini is not liking that. The bevel is not working as we expect. Let's try something else. Let's delete this geometry, and let's delete both of them. Let's delete top and bottom. So delete top and bottom, and let's put down a polyfill. And let's change this to triangle fan triangles. Yeah, this is much cleaner, but I don't think the bevel is gonna work now. So let's do a bevel again and set this to 0.01. No need for edge selection. I'm gonna apply it on everything and then turn on ignore flat edges. Yeah, it's much better. See, okay. Let's increase the chamfer, and now we've got some cool shapes. Let's see if that still works. Yep, it's not working. It's a very messy operation. So let's just disable this. You can hold the B button and then drag, and let's just use this one and swap it and swap this one, and we can also do it as a post process here. It's fine. And then if we combine everything else, we've got this cool indentation now. It's not very cool, but I think you guys got the idea here. Okay, let's do one last operation. So we have a very sharp edges everywhere, and let's actually connect the other parts as well. Let's put down a bevel node, and try to get some interesting bevel happening. So let's increase this to 0.02. Set this to 2, maybe 3. And ignore flat edges. And increase this a bit. I think the amount is too high. Let's try 0.05. Yeah, 0.01. Even less, I think, 0.05. So we don't hurt all the entire geometry. And I think we have some cool shapes now. There's some weird edges here, but I think this is enough for now. Now I do like to add a divide node here to triangulate everything, and that's going to give us a much cleaner and renderable mesh. And then if we turn on the poly bevel, it's going to also work. Maybe it requires a bit more control. But yeah, I think we're good now. All right. So that's our new element, and the way this has been used in the previous result is basically the same. So I'm going to copy this. Actually, let's copy some a mirror node. Let's do it here. I'm going to mirror this result along the z-axis. And I'm going to copy it now. And that's going to be our side elements. We can scale them down. We don't need in this case. But yeah. And this is what has been used in this example. So if I go here, this is the elements underneath. And yeah, this is the elements that we just built. And then we have this section in the center, which can be replaced with the new one that we have. So let's, I'm going to build this one in the next video along with the pipes. And then we'll start going upward and build the bottles and these designs as well. But the idea is pretty much the same, except with few modifications. So let's continue exploring and see what we're going to build. Thank you for watching and see you in a bit. Hello everyone and welcome back. So let's continue creating a few assets. So we're going to focus on creating this ground here, and then we're going to place some pipes underneath. So I'm going to build this from scratch. I'm going to start with a box. And let's just isolate this one and look at the front camera by hitting space 2. And now we're looking through the top camera. Let's find a front camera. This is the one I need. And actually, let's go to the viewport and hit enter. And I want to make this thinner, so I'm going to move it up. Just do it in the viewport. I'm going to hit the fourth key, and it's going to change the selection mode to primitive. You can see the shortcut. And I'm going to select the side I want, hit tab in the viewport, and type in extrude. I'm going to move it to this side, look through the front camera, so space 3. And I'm just going to press the T button, the T shortcut, and move this down like this. Could probably rotate it like this. Yeah. Let's move it further, something like that. No, I think that's too high. Sorry. Half of this. Now I want to make this more interesting. I'm going to create a box. We can just, yeah, I'm going to create a box, and then let's template this and move this box to the side and just rotate it. And I'm going to place it so that it intersects with my geometry. And I'm going to mirror this one along the, I believe, the z-axis. And now I have the same thing happening from both sides. I'm going to use a Boolean operation, and I just want to cut the corners and make this look more sci-fi like. And now we can select the box and move it in and out to decide this. And we can also rotate it. Right now it's 45 degrees. We can change the angle to anything we want. I'll keep it 45 degree for now. I'm gonna select this primitive. I'm gonna select this primitive and hit tab in the viewport and type in blast. And this is gonna create a blast node. I'm gonna hit the Alt-E shortcut to disconnect this, and this has been remapped from here. Disconnect, reconnect around selected. So Alt-E is my shortcut, and then I'm gonna tick on delete unselected. So now I have this primitive. I'm going to select 2 points from it. Let's see, change it to selection. I'm gonna select these 2 points and bevel them. Let's increase the bevel. All right, let's go back and let's extrude this geometry. Poly extrude up and output back. I'm going to transform it down, so make sure it's intersecting with my current geometry. And let's template this. Now this is too big, and I want to change it so that there's a gap here. And I'm going to do that by just scaling this primitive here. So I'm going to select it, press the R button or E button, and that will give me the scale transform tool. I'm going to scale it down. I also wanted to be go past this geometry, so I'm just going to scale it along the x-axis and move it back a bit like that. And now my poly bevel is going to work, my extrude is going to work, and my geometry is going to work. I'm going to put down a Boolean node again, and Boolean this one with this one, and now we have the intersection between the two geometry. Cool. Let's continue. I'm gonna take this geometry again. Let's create a null, and let's see. Actually, I don't want this to go all the way down, so I'm just gonna move it up. I want to create some indentation like this. And I'm gonna take this geometry, and we have that Side Effects Labs tools. They have a lot of interesting nodes. I'm gonna use one called Lot Subdivide, and this will take any input geometry and try to subdivide it in an interesting sci-fi like pattern, so we get these nice shapes. And I'm gonna use a polywire node and reduce the radius to a reasonable number, and let's change the division to 3. Turn off prevent joint buckling. I think this is fine. I just need this geometry basically to use for intersection. I'm gonna set this to 4. Let's go back here. I'm gonna do another Boolean geometry between this and this, and let's transform it so that it's intersecting with the geometry in an interesting way. Let's template this one and let's move it down. And let's see what we get. Awesome. So now we have this pattern embedded into the geometry. Let's move it up and do something like this. Cool. And let's continue. So the next thing I want to add is a cavity here, or a Boolean here, to add some steps. And let's do that by taking this side and working on it. Okay, let's try to create a box. Another box, and place it and see what the detail is going to look like, then go from there. So here, something like that. And before we operate on this, we also need to apply the same cutting feature that we had and maybe transform it a bit. So let's put down a Boolean node and intersect these two. And let's make this higher. Okay, let's select the box. I'm not going to bully it. I'm going to select these two edges and just bevel them. Hit tab bevel. And I'm going to look at the top view and try to get this detail in. And that's enough for what I need. Let's put down another Boolean node, and between this and this. And now we have the gap. Okay, so let's try to create some stairs to fill in this gap. I'm gonna create a box, or take this one, duplicate it, and I need to make it smaller, something like this, and let's move it down. Or actually, let's move it here. to create the first step needed. And I'm gonna ignore this part, and the step probably gonna start there, the first one. Okay. And let's use a copy and transform node. And let's template this, or the entire geometry. And let's move the step copy, something like that. And let's generate as many as we need to fill in the gap. And let's move it so that the step follows the shape. Yeah, 5 is enough. And let's cut all of this to make sure it fits the space correctly. So let's make it a touch bigger. And this is my intersection geometry. I'm going to put down a Boolean node again and intersect the two to only have stairs where they have to be intersect. Cool. So let's merge this with the geometry. And now we have, actually this is the geometry. I'm going to turn off texture, and I'm going to turn off display color, display texture. Where is it? And just use a white color for now. And this one is going to happen here. And this is my merge result. And now we have some cool sci-fi shape. So let's add a couple more details to this, and then we'll call it done. I also think that this gap is too much, because this has to be flat as much as possible. So let's try to fix this. So here we did a Boolean with this. I'm not gonna do this part. I'm gonna skip it and only add details to the top layer of the geometry. So let's move it up. Okay. Cool. Let's try to add more details. And I think we can do that using this one. So really what I don't like is this big gap, but I do like to have a gap. So here's what I'm going to do. I'm going to take this geometry. I'm going to take all of this. Actually, just delete these two, these three. Hit the delete button in the viewport. And now I'm going to extrude this geometry. Give it some thickness. Output back on and push it in. And I'm going to put down a reverse node to revert the normals. And let's use this one to get the Boolean. And that's the detail I was looking for, to make a cut there. It's too deep, so let's move it up a touch. And now we can add our extra panel detail. We have this nice seam and separation, and then our detail that we want. Let's continue. That's the stairs, and that's combining the steps. And let's put down a mirror node. We're almost done creating the important parts for this geometry. Just gonna mirror it. And boom, we have a nice ground element that we can place. Let's create a null and call this out ground base. I'm gonna hit the shortcut I have, Alt Shift E, to create an object merge. And let's go to this side. To this side, and let's paste the ground, and let's scale it to fit in space in the correct position. Let's template the mirror node. I think it's too big and we need to rotate it. So let's move it to centroid. Let's rotate it 90 degrees and let's scale it down. Now we probably could fit two of them. And I just started with the box, like I didn't have any clear scale in mind, and I know I can simply scale this down. So I would expect this to be two blocks to to fill in this object. So I'm going to use a copy node, copy and transform. And I'm going to move it and place it so that it's in the center. Okay, let's combine this with our geometry here. And let's copy everything. I don't think we need this transform. We need here to scale this down if we have to. It's fine. Okay, that's our connection or block geometry. We're gonna add the grid-like metal structure to fill in the gaps. So let's add the metallic part and keep on adding more stuff. Thank you for watching. See you in a bit. All right, let's continue and add some more details. So I'm back into this geometry, and we plan to copy this geometry at least once to fill in an entire block. So I'm going to do that. I'm going to put down a copy node, copy and transform. I'm going to move it, and I think this will be enough to fit into the ground element later. Obviously, it would be better to do this live and interact with it, but I think you guys can figure this out. I'm only interested in showing you how I would approach doing this element. So I have two blocks, and I'm going to select these and this, and blast them. Tick on delete non-selected, and this is my geometry. With the mirror node, it's not connecting these two, and I'm gonna move it so that they are both aligned exactly. And to make sure that everything is fused, we have a fuse range, but I'm not gonna change that, and put down a fuse node. Maybe increase the range a touch. And now everything should be connected. Yeah, by double clicking, you can find out that. You can also use a point mode, select a point and move it. And everything is connected. So let's put down a divide node, because I want to get just the silhouette. So tick on remove unshared edges and convex polygon off. And I'm gonna put down a bridge node. Gonna connect it. This is a bit tricky to use, so that's why I'm gonna create it in the scene first, connected, and then we need to fill in this. So I'm gonna start in order, or let's just select this one because we only have one, but the order is very important. So I'm gonna select that, click here on the arrow, select the primitive and hit enter. Then go to the second one, select the next primitive and hit enter. And by doing so, it's gonna bridge the two geometry together. Let me see. I think we made a mistake on the deletion. Yeah, I think we didn't delete all the pieces we need. Let's go back and fix that. Fuse them, divide, and let's bridge, and there we go. And what I'm interested in is only the top part. We don't need the bottom part. And I'm gonna use a delete node and delete everything by normal. So if a face is pointing up, I want to keep it. If it's pointing down, I want to remove it. And go to the normal tab, create a delete node, go to the normal tab and set the normal to point to the y-axis, and let's play with the angle. And boom, there we go. We already deleted everything that faces up. So I'm going to change the operation to delete non-selected, and this is what we have. Let's put down a divide node, untick convex, and tick on breaker polygon. And let's scale down. Yeah, let's scale down all of this. And what I'm going to do is I'm going to copy this and paste it here. I don't need anything on the y-axis, so I'm just going to set it to a really high number. And this is what we're interested in. Set it to 0.05, 0.04, and boom. You have some nice pattern. I'm going to move it I'm gonna move it there and maybe move it in the z-axis so it looks symmetrical. All right, let's put down a polywire node. And actually this one I wanted to make squares only. So let's use the inset method. Let's put down a poly extrude node. And let's take and check output front and turn on inset and then change it to individual. And there we go. Maybe not too thick. Let's go. Yeah, it's not gonna be able to go further. So let's try something else. Let's see if I can make this work. Let's try put down a facet node. I'm not sure if this is gonna work, by the way. I'm gonna put down a facet node and take on unique points and cusp polygon. And what this is gonna do is gonna separate each primitive into its own. So everything is unique. And if I middle click, you can see here I have 7, 20, 20, 6, 6, 3, 3, and here I have much more points and then the same number of primitives. So each primitive is unique. You can see it's selectable as well. Let's put down a primitive node, click on do transformation, and just start scaling the primitives. And what we need is we need the inverse of this result. So let's extrude all this geometry. Let's extrude it, turn on output back. And let's peak it a touch because I want to move it down. Let's peak this geometry just a little bit like that and then extrude it. And let's do a boolean and see what we get, see how bad it's going to be. Let's boolean this geometry with this new one. And the second input, the first input is a flat plane, so we have to specify that in the boolean node to set it to surface. And now we have our grid structure, or at least more control as to how the grid structure is going to look like. And I'm going to extrude this, give it some thickness. And we don't have to take on output back. I don't think we need it. And I'm going to try to bevel it. Maybe it's going to work. Let's see. Yep, it's working. And yeah, it's working in the majority of the cases. Let's put down another divide node, triangulate everything. Let's maybe fuse all the points together as well. And let's see if the bevel is gonna work better. Yeah, it's definitely better. So let's reduce it to 0.025. And now we have some nice bevel happening. And we can also include use the exclude flat edges and only run it where we have corners. I like this. So let's connect it. Let's add it back to our geometry. And that would be this one. Actually, let's disconnect this and connect it here. That's going to be our output. And this is the object merge. And we did this copy just to get the intersecting geometry, but it's not here yet. So I'm going to paste it again. And now if we merge this, we have the result. I'm going to also copy. Let's see. Let's do the copy after because we want to propagate this. And let's go back to the environment. Not this one, this one. And now we have the grid structure added, but I don't need the copy anymore. And I don't need to transform it all the way. Actually, we do. Let's just move it like that. And let's see how it's going to look like. So now we have our grid connecting the pieces. Maybe we give it, maybe push it down a bit. Let's try that. Let's go here. And I think we can do it this way. So I'm just going to select this one, use a peak node, and just move this geometry a touch, run the same operation, poly extrude, everything looks good, and let's come to this side, and everything looks good here. Alright guys, I'll continue adding some more details in the next video. Thank you for watching, and see you in a bit. So far we've gotten to this point, and I would like to add some pipes underneath this structure. I want the this to basically be on top of this section. So what I'm gonna do is I'm gonna move one of the sides, and that will get reflected and push them apart. So let's put down a transform node here and just move this out, and that way it's only intersecting with this segment. Okay, and let's visualize this, and I would like to add some pipes in this area. So let's create a line node, hit tab and type in line, and I'm gonna aim it to point in the X direction, and let's move it here. Let's reduce the length so it fits the space, and let's increase the number of points to 10. And if I visualize the points, I have this much, maybe just 6. No, let's do 10. Let's change the mode to selection, and let's pick 2 points. Press the T button, and I'm gonna move this to the side. I'm gonna put down a poly bevel. I want this to have, nice metallic like transition, so basically bend this to have a nice rounded corner, and same here. I'm gonna put down a poly bevel and select the points that I want to affect, and that's gonna be these 4. Let's increase the size to 0.01 because the scale is too small for this, and let's increase the round to 5. Yeah, this looks good. Let's try 1.2, 2.5, and I think the angle is good, but the initial shape is not that metallic. It's not representing a pipe transition. So I'm going to select those 2 points, press the E button on the keyboard, and just scale this up. And now if I look at the result, I'm going to have nicer angles between the sections, something like that. Okay, let's put down a poly wire node. It's going to take the curve and make it into a tube. I'm going to increase the division to 16 and reduce the size, the width to 0.01, and now we have a nice pipe. So if I press the W button, you can see the wireframe. We don't have a uniform resampling, we don't have uniform edges going through this, and I would like to fix that at the point level. So I'm going to go back to the edit. Actually, after the bevel, I'm going to visualize the points, and this is what we have, and I want the points to be uniform. I'm going to put down a resample node. This is going to take any curve or any input data and try to regenerate the points and resample them. I'm going to set this to 0.01. Maybe we need more, 0.05, 0.08. And let's take a look at the poly wire. You can see now we have a nice distribution of the polygons. Let's increase this to 20 to make it more rounded. And we can continue with this path though. So we have this curve. I'm gonna put down a null node just to separate. I'm gonna use the same curve, and let's transform it, and let's visualize this result. And let's also display this section, make sure that we're not intersecting with any other elements. And I'm going to, I don't need the null. I'm gonna change to selection mode. Select 2 points again, and maybe 2 points here. Press the T button, and I'm gonna move this. Okay. Let's do selection again. I'm gonna select these 2 and scale them up. And also this point, I'm gonna just press the T button and move it here. And let's merge all of this together. And let's take a look at the poly bevel. We have to specify the points that we want to bevel because we don't want to affect everything. So I'm gonna select these 2, this point, these 2, and these 2 points. Now if we take a look at the resample, we have some nice pipes. Maybe this one is not that interesting here. It's fine. We'll leave it at that. So we can continue with this way. We can just copy this one as well, transform it again, and move it. And maybe because the poly bevel needs a point selection, I'm just going to copy it, but copy it as a reference. So which means that anything that I change in one of the nodes, let's color it with green. If I create copy reference, right click, actions, create reference, copy, these nodes will have all linked parameters to this one. So this is the main driver, and I want that, but I do like to change the point selection to fit my individual inputs. So I'm going to break the connection, and I can override this data on this node specifically. So let's select this one, and let's select these four, and let's merge them here. And now we have the same result. So let's go back and update this. And I'm going to select these points and no scaling. I'm going to select this point again, and I control click on the node to reset the setting. Let's update the selection as well of the points we want to bevel. Now we have something like this. I'm going to do one more. Let's try to mirror this. I'm going to turn off keep original, so I just invert this data, and I'm going to clip it along the x-axis, so I only keep half, like this. Maybe this curve we don't need, and then I'm going to mirror this again. So see, I clipped it and then I mirror this, and it's going to be different. So let's reverse this result as well one more time, and we're going to have something completely different. Let's mirror this along the z-axis, maybe. Yeah, z-axis is good. Turn off keep original. I'm going to template this and try to overlap these two in an interesting way, but without having them intersect massively. So yeah, let's move it this way, and then we're gonna I'm gonna merge all of this together, resample them, and take a look at what we get. So far we have a lot of intersections, so let's go back and fix that. I'm going to change this to primitive, and let's move this to the side. Let's move this here, and let's move this. Actually, I don't need this one, so something like that. And what we can do is we can run two separate ones. Let's resample them with the same node. So I'm going to just Control C, Control V, and the polywire, I want to use the two different nodes as well. So the second one is going to be half the size of the first one, and now I have a different pipe selection. So let's clip all of it from both sides, make sure that they're all aligned together, and let's template this one and make sure that we're clipping the geometry nicely, and I will scale it up a bit and delete. Same, I copied and pasted the clip, inverted the selection, and I think something like this will work. And let's put a transform node and try to get this to match the shape that we have. Sorry, select this, and gonna, instead of doing that trick to move centroid, I'm gonna use an expression here called $CEX, $CY, and $CZ, and that will place the pivot to be at the centroid of this object. So now if I scale it up, it's going to be always in the center. Right, let's put down we don't need to put down a polyfill because I plan to mirror this same way with all the other elements. So let's move this down here, and let's merge this together. This is what we have, and then if we copy it, the pipes are going to be copied together, but they're not mirrored, so that's why we have this this gap here. So we can fix that by doing this. gonna change the pattern, unfortunately, but this is a quick way to do that. The other way is to make the lines all the way, extend them all the way to cover the entire section, and then change the variation as they go. But for this one, I'm gonna do just a quick hack. Clip it here, and then mirror this. And now when we copy them, they should blend in nicely, except this area. Let's see, why is that? Yeah, this one is not ideal. So let's go fix that part. So let's find the points. And I'm gonna delete these points. And I'm going to select them again. Push the E button and just scale these 2 points. And now once we clip, scale, and then clip again and mirror, it should connect nicely. So that's a quick and easy way to hand place pipes under this structure. And I'm gonna take a look at other ways to create something more procedural as we learn more about Houdini proceduralism. Let's move this up. Something like that. All right, let's continue adding some more pieces. Thank you for watching, and see you in the next video. Hey guys, and welcome back. So let's continue adding some more elements to our environment, and we're going to build the outer structure of this shape. So let's go back to where we are here. Obviously our scene is much smaller. You know what, I'm going to scale it up. Let's scale it up here. Let's make it 10 times bigger. And then if we copy it, we need to change the copy to be 10 times wider as well. So let's create a box, and I'm only interested in covering one section. So let's create a box, and let's move it to this side. Make it bigger to cover all of this. Okay, and let's add some interesting sci-fi details. So I'm going to select one of the edges, this one, and I'm going to bevel it, and let's increase the bevel a bit more, something like that. I'm going to transform this. I'm just changing the viewport, so I'm copying it. I'm going to template this one, take the transform, hit enter, and it's somewhere else. So let's center it. $CX, $CY, $CZ, and let's move it so that it intersects, something like that. Okay, we can make it bigger, and I'm going to use a Boolean node and intersect both of these to get the silhouette like that. Let's create a box, or just take this one and transform it. I'm going to take this box, and let's set the expression $CX again. $CY and $CZ. And what I'm going to do is, because you keep typing this quite a bit, I'm going to right click and say save preset, and I'm going to call this center pivot. I'm going to save the preset. There's some issue with my settings, but that's how you save it. And then later on, we can just use this menu to say load in one of these. It will show up here. You can see already with the labs and the QLib tools, there's few things that has been added, and I believe this one does that as well. Yeah, this is the same expression as well. Okay, let's scale this. And let's make it bigger, and let's move it all the way here, and let's use a copy node, and I'm going to move this copy along the z-axis and increase it, and let's try to get this to be in the center. So I like this one. Maybe we make more pieces. Yeah, and let's reduce the offset. All right, I'm going to use a Boolean node and intersect all of that with this. Now we have this cool shape. I'm going to keep adding to it. I'm going to transform this box again. Same one. And let's use that same expression, centroid node, and let's move it. And let's scale it like that. Make it wider and going to intersect it this way. So see, the centroid is not aligning to the object. I'm going to right click, say align to object, and that will be local now. And I'm going to intersect it this way. And let's make it bigger. And use this as a Boolean as well with my geometry. And now we have this cool shape. So let's make it more interesting. Let's go to this box here. I'm going to select two edges. I'm going to press the W key on the viewport. The number 2 key on the viewport, and that will give me the edge selection. I'm going to select these two, bevel them, and let's increase the radius, distance, and see how that looks. Let's continue adding some more. I want to make some holes here. So let's copy this section and let's template this. And what I'm going to do is I'm going to move this to be in the center of the piece approximately. And I'm going to scale it down, and I'm going to rotate it, scale it down as well. And I'm going to select all the edges, and I'm going to bevel them. I want this to look more interesting than just a box. So bevel, and let's copy it in a way that it aligns with the individual blocks. So there we just need 4 copies instead of 5. And now let's do one more Boolean operation with this. Now we have some nice holes added to this with some interesting shape rather than just a flat polygon. Maybe make this go something like that. Okay, let's add some details here. So let's go back, let's copy this same thing, and I don't need the deletion. And I'm gonna move this box up so that it intersects with this block here. I'm gonna move it up, scale it, and I'm gonna scale it down as well and move it to the right, sorry. And before this copy, I'm going to use another one to make this geometry, to duplicate this geometry a few times. So increase the copies and move it this way. And this is similar to that event feature that I'm trying to create, did previously. So let's move this to fit in. And then if we apply the same copy, it's gonna do that. All right, let's try this. And now we have some nice vents. Let's make this a bit more interesting. I'm gonna take these two and I'm gonna move them out and up. And I'm going to select all the points that they have at the bottom and align them with everything else. I'm gonna select these points, and change the viewport camera, press the T button and move them down. We could also do the same thing here to align all the features together. Oh, the edit is happening at the wrong level. I wanted to have it, actually this is fine, yeah, this is where it should be happening, sorry. So I'm going to do that move again. Now we have some nice indentation. Let's put down a mirror node. I'm going to mirror this upward. So along the z-axis, y-axis, yep, select the mirror node and move it up. And then I want to make the same copy here. So I'm going to take the bottom one, and we can use that same that transform expression. And I'm going to rotate it, I believe this way. like that, and move it here. I'm gonna have these two intersect, maybe something like that. Let's merge all of this. And now we have some nice coverage for our geometry. I don't like this detail that much, so let's go back and change it. This one is not working for me, and let's find it. So what I'm gonna do is let's leave the bevel and go here. I'm gonna scale it down. It's working live on the entire geometry, which is pretty cool. Let's move this up, and I want to just make an indentation on this one. So let's display this result, and let's continue playing with this. Yeah, just a panel basically, and then maybe we can try to play with the division instead of just a single one. Yeah, I think this is more in line of what we want to do. Let's merge this with our awesome ground element and see how it's going to look like. So this is the copy. And again, I want to make the copy all at the same time. So I'm going to merge before this, merge the environment, and maybe move it, position it so that it makes sense. I want it to intersect with this piece here. All right, and now let's mirror it as well along the z-axis, and let's move the mirror center to be where we wanted it to be, something like that. And now we have to edit some of the geometry to fill in the gap. Let's try something. So I have this one, and maybe let's do one more mirror node at the top along the z-axis, and let's move it all the way here, and let's connect this one instead. Now if we do a mirror, we have coverage from both sides. So let's duplicate all of this and take a look. So this is it's not exactly the same, but very similar to what we have built. Obviously the ratio is different, so we need to work on that a bit. Yeah, I think it's just a matter of moving this structure in and making the ground a bit smaller to reduce it in width. I mean, we can scale it down, but it's going to squeeze all the detail. Yeah, I think this ratio is better overall. And we're going to continue adding a few more things to make this even more interesting, and then wrap it up and start building more elements. Thank you for watching. See you in the next video. Hello everyone, and welcome back. So we've got to this point and we have all of this built, and let's find the instance where we are duplicating things. So this is the point I like to start from, and I want to add some details here. So let's hold the Alt key and drag. That will give me a point, and I'm going to put down a delete node, and let's untemplate everything else. I just double click here and that will get rid of all these templating options. Turn off the delete, go use the normal, and I'm going to delete anything that is facing the X axis. So let's reduce this down. The Z axis. And I'm going to change it to delete non-select. And the idea is I just want to isolate certain section of this build, and that's good. Let's duplicate this again, and I want to use these Z or X axis and to get these shapes. And I don't want to include this, so let's try finding a useful information. Yeah, so we can get the geometry from before we did that blend to just isolate these sections. So let's combine these two, and I'm isolating them to add more details to these areas. So let's put down a subdivision, lab lot subdivision, and as you can see right away, it just split it in an interesting way. I'm just gonna use that. I'm gonna put down a color node and a facet node. Facet node, make sure everything is unified, so all the primitives are separate. going to put down a color node and change it to random, and it's per primitive. And let's make sure I'm displaying my geometry color. And now we have this. Let's put down a extrude node, poly extrude node. I'm going to tick on output. Oh, we don't have to tick on output back. Let's increase the distance. You can see they're all moving at the same depth. And there's a way to control this. So let's go to the local control and distance scale. I'm going to turn on. By default, referencing an attribute called Z-scale. I'm going to use CD, which is a color attribute. And that color attribute has a luminance or has a value. So we can still use a vector to drive this. You can see now each one is different. And let's turn on output back. And we can just merge this with our existing geometry. Back. So here we're merging all these nice blocks. And I'm gonna delete the color attribute. So let's put down attribute delete here and delete the primitive CD attribute. And now we've added interesting blocks to these areas and these sites. Go back and we can apply this technique to pretty much everything we want. I also wanted to show another alternative fix because sometimes when I'm working live, I forget solutions. So we clipped it and we lost the details, which I was not super happy with. So what we can do is, the main reason we want to merge this with the environments that we want to do a single copy, but we don't have to. So what I'm going to do is I'm going to make this tileable. I'm going to put down a mirror node. Let's copy this one. Here, I'm just going to move it so that it overlaps. And now I'm going to move this all the way down. And instead of using the same copy, this now represents 2 units. So I'm going to copy this node here. And let's delete the expression and template this. See, it looks like we have a scale issue. So let's copy this as well. Here. Here. Okay. So right now we have this node, but we need half of the duplication because this pattern, this pipe pattern is only covering 2 blocks. I'm going to change this to 2 and I'm going to increase this by 2. So multiply this by 2. And now we should have coverage for the pipes and we didn't lose any details. There's something here overlapping. That's just because we need to fix the geometry a bit. Maybe update the offset, because the geometry is not exactly matching the same bounding box. And I'm gonna merge all of this now. We have added more details. I did just copy this and mirrored this section, but we can always copy all of this and create an alternative version so that this top is not the same as this one and not the same as this one. But I'll leave it to you guys to explore that and add details as you see fit. All right, the next section is I'm gonna copy an existing network, because at this point pretty much all the techniques that I've covered are the same. And the last element that we're missing at this point is this section here and the bottles, which are pretty simple. So let's paste this graph here, trying to get it from a separate Houdini file. And so I have the trace, which is the same one we've used, and a transform, and then I'm isolating various sections. So this is the final result, and let me show you how it's built. And we'll provide all of this, so it should be straightforward to go over it. So the first thing is a transform, and then so I'm isolating various parts. That would be the first one, second, third, fourth, and fifth. And then each one of them is being extruded and transformed in various ways to make an interesting shape. So this is the first one. The next one is this, which is this shape here. Poly extrude, group the edges, bevel them, and then normal node to fix the normals, and then a transform to rotate it this way, and a mirror node. Next is this section. Same thing, extrude, polybevel to give it some interesting shapes. Isolating both sides and then extruding them this way using the same lot, subdivision, color, and poly extrude, combining that in, and then transforming that like this. And then the same thing, another shape that's been mirrored. It's coming from this one. So mirror that, copy it, and let me combine all these four shapes. And honestly, all this was built like just trying to create something that looks interesting. We had no reference, we had nothing. We're just trying to combine and kit bash some stuff in Houdini. And then the second block is built from this shape, some extrusion, some copying and merging, and then we have this one as well. Boolean to create a cavity, mirror this one, and then combine it with this shape. And again, we'll provide the file. It should be straightforward to just take some shapes, combine them, and we're going to continue exploring this idea. By the way, like we still have the entire environment from the chase intro, the previous one, that we're going to cover as well. So this is the last element that's missing, and this edit here just moves the points down. I'm going to create an object merge and drag this here, and let's copy this object merge and go back to our environment and place this object so that it goes along with what we have built. So this one, let's put down a transform node. Let's move it up. Let's rotate it this way. Obviously, the scale and size is not the same, so it's intersecting quite a bit. Maybe let's add it here. Yeah, something like that. And let's mirror this object as well, so it's on the other side. And now if we copy it, we'll get this cool shape. I think we need one more copy inside to fill in the distance. So let's just copy it and move it. And now we have pretty much built the same environment. Let's create a camera and position it, and let's make more copies to cover all of this. So here I want to set a number that controls all of this, so you can copy this and just make the pipes relative to this. So paste relative reference, and the pipes should always have half of the main one because they cover 2 units. And let's increase the copies to 12. And now we have our awesome corridor built. Very cool, guys. Very cool. All right, we'll continue exploring and learning some more about Houdini proceduralism and how to build cool stuff. Thank you for watching, and see you in a bit.